All right, welcome back, everybody. Welcome back. So today we're starting off where we left off from yesterday, which is we got most of this frame assembled, and now we're just going to keep on going with the build. So this isn't a fast process, but it's one we're going to go through step by step. A little behind the scenes work that I did. I sourced some components that I'm going to need later on in the build. I wasn't sure what stepper motors I was going to use, but I got these basic Creality extruder stepper motors. So I'm going to use those for the X and Y motion system. And I think that'll make this a pretty good test bench for seeing different upgrades and how much they really affect your print quality and speed. So, you know, these are pretty basic motors that are the correct size for this application. But if we get something like the LDO super speed motors or some other fancy brand stepper motors, we'll see how much that actually increases speed. So I've got these. I'm going to set those aside. And I've got a vintage power supply here. This is a 350 watt Meanwell power supply, back when Creality was getting their power supplies from a reputable brand. Now they're doing the whole DIY power supply thing, and I'm not sure if they're going to be as high quality, but that's fine. So, last episode we finished up by installing these front and rear mounts for the Y-axis, and I think I'm just going to pick up where I left off by putting this motor on over here. Okay. So I'm going to pull up the instructions yet again and get started. Alright, and welcome to the chat, Jay Cannon. Good to see ya. We're going to be doing a longer stream today, trying to get as much of this done as possible. So, here goes. Alright, so as we can see from the instructions here, we're going to be, we're going to be building up the Y-axis, making sure this is all put together right. So I kind of half-assed this yesterday, but we got to finish this up. So put these screws on for the stepper motor, as well as that belt pulley there. I think I already have everything out and ready to get started with that. Yeah. Okay, so I just skipped this step right here, assemble the Y-axis motor mount, so I'll just do that part right now. Alright, and I'll be checking in on the chat periodically, so just let me know if there's any questions you have during this process. So, Cider, welcome. Cylinder, Cywunder, not sure how to pronounce that, but welcome to the stream. Steve Stout, what's your impression of Ratrig? Well, it's incredibly well built. Like, this thing is super sturdy. Like, I could probably drop this off the table and it'd be fine. If I just, you know, took this whole thing and tossed it on the ground, it'd probably leave a dent in my floor. So it's incredibly well built, and they've done a really good job of securing these components together. Like this, there's 3 points of connection, which is always pretty much what you want to make something really strong. They've got this buttress up here with these 2 components, and then down here as well. And then same on this side, they've got all these different supports there. That's going to make this thing incredibly sturdy, and these are basically one piece, the way that they're connected together so well. So I think Ratrig's done a really good job of making a very structurally sound printer here. My only concern is how long it takes to put together, and I know a lot of people are going to enjoy that process of building this, so you really get a long ride in terms of how long you get to be building this thing. So It's not like when you get on a roller coaster and you're like, wee, and then it's done. No, you're in it for a while when you start putting this together. It's more like one of those really long road trips where everybody hates each other by the end. Okay, so let's start putting this together. Instructions. Also, their instructions are pretty good, so that makes it kind of a fun experience. It's kind of like reliving the fun of putting a Lego kit together. But since you're older and smarter, the kit has to be more difficult to compensate, so it's pretty fun. Alright, so I need some screws here. I think M3x8s, so these short ones. Alright, so these 4 screws we'll put in on here. And I got a lot of complaints yesterday about not having the right tools. So I got a full set of Allen keys here. And you're probably going to complain about these being standard instead of metric, but I think it'll work fine. Actually, I don't think it'll work fine. I think it's going to be a pain, but I don't have a full metric set. I get a little bit more use out of my metric sets, so I lose them more frequently. So I don't currently have a full set of metric Allen keys. Hello Herzl, welcome back. Did you print the parts yourself? Yes, I printed these mostly on my Bamboo Lab P1P. And I printed a couple other, and about 30% of the parts I printed on my Ender 5S1. The Bamboo Lab P1P did a great job at printing these parts out, in all honesty. It was basically, I just loaded the filament up, told it to print, and then boom, I have all my parts. The Ender 5S1, I had to do a lot more tuning, but at the end of the day, it's working now, so that's just the experience that you get when you have a DIY kind of printer, like what you get from Creality. Yeah, so I had to tune that up. It's working great now, very reliable with my PETG, but it's one of those things where it's like, I wish Creality would just do a little bit more homework and give you some nice tuned print profiles so that you can just get right to printing right away instead of having to mess around with it for a couple hours. But I've gained a new skill. I can now print PETG and make PETG profiles for all my printers. So you end up learning more by going through that process, but it also takes longer. All right. Of course, I'm missing the right size Allen key when I need it. Ta-da. All right, that's all assembled now. I'll just torque this down a little bit. One thing I'd really like to see on this kit is if they were able to just print out this whole assembly here. Like if you just took all of these components, this whole thing, and just printed out this whole frame shape out of like a carbon fiber nylon, and then you had the mounts to just bolt these motors on and attach everything and bolt these linear rails onto. Like you could probably make a pretty sturdy structure out of a gigantic monolithic carbon fiber nylon print. And that would be pretty cool because a lot of the work on this machine is just putting all these fasteners in. There's a ton of fasteners on this machine, and that's kind of what you have to do when you're using this aluminum extrusion stuff. But it ends up taking quite a bit of time to just sort out the fasteners, find which one you need, and screw them in. You got to find tools to fasten each one. So, you know, all this time that you spend looking for Allen wrenches is all kind of non-value added time. I don't want to say it's time wasted, but it is. It does consume some time in a non-value added way. Okay, so that's all done. This front piece might be done, but let me go ahead and screw this bolt in the back, and I'll do the one in the front. Now this is an M8 bolt, so it's a metric size, but I'm going to find the closest fit with my imperial bits. All right, that one just barely doesn't fit. We're going to go with the 7/32, which is a completely logical way to measure things. 7/32 of an inch. Everybody knows what that is off the top of their head. All right, screw that in. And then on the front, we'll screw this one in too. Oh, does the video look underexposed? I can turn that up. I guess because the background's white and the part that I'm working on is black. The auto exposure is gonna kind of miss the mark there. But hopefully you can see what's going on a little better now. We got a photographer in the chat talking about underexposed, overexposed. Herzelnerk wants you to check out Discord. Okay, I'll take a peek at Discord. The tool torture continues. Yes, it does. I think for these larger bolts, it's not as big of a deal to use the wrong size Allen key, because it's not like I'm tightening this bolt down with 30 Newton meters of torque or something. I'm basically just getting these hand tight because we're tightening it down into a plastic part. So if it's the wrong size and that meshing with the actual the fastener isn't perfect, it's not that big of a deal because we're not putting a bunch of torque down, in my opinion. That's my unprofessional opinion. All right, so I think that finishes the Y-axis assembly. And we're ready to move on to the next step, which is Y-axis carriage and bed assembly. So let's take a look at this. All right, so next step here, I've got to get my belt. I hope, yep, they provide the belt. So we've got Y-mounted belt. Now there's two belts in this kit. One is 6 millimeters, which is used for the X-axis. That's the thinner belt. And the other is a 9 millimeter wide belt. Both of these belts have the same pitch. That's the spacing between the little teeth, but one's thicker than the other. So the thicker the belt, the stiffer it is, and that'll help compensate for that extra weight that you have on that Y-axis. So the bed slinger part of it. A lot of people complain about bed slingers not being optimal or whatever, but I don't think that's true, because you can spec up the motors and belts on the Y-axis as they did with this kit. And just by beefing up the Y-axis, now all of a sudden, the fact that the moving masses are different doesn't really matter. You can just compensate that with good design practices. All right, so we need some locking nuts. 4 M3. I'm going to set them aside over here if you want to watch the pile of bits build up. All right, we got our belt, got our M3 fasteners, 3 M5 locking nuts, 2 M3 by 25 cap screws. Okay. I think these are right. And with my handy calipers, I'll just measure them to make sure I've got the right one here. Yep, 25 millimeters, we're good. So I need 2 of those and 2 M3 by 16. Pretty sure that's these right here, but always want to verify that you're using the right fasteners. And that handy step measurement that I was talking about yesterday, you can also use it to measure fasteners nice and easily. With socket head cap screws and button head cap screws, you're going to measure it like this, where you're measuring from the flange of the fastener, or that mating surface where you tighten it down against, out to the tip. And we've got 16 millimeters. So that's the right one. I just want to give you a little tip here. So that's how you measure a socket head cap screw. But if you've got a flat head cap screw, like the ones that have the little chamfer, little 90-degree angle built into the top of them, I just got to find some here. I really like how, here we go. So these countersunk screws here, they're called flathead cap screws. But if you pull one of these out, you actually measure these differently. So on our normal fasteners, we'll measure them like this, and measure from, you know, the bottom of the head of the screw to the end of the screw there. But for flat head cap screws, we measure them like this. So this is a 30 millimeter long screw. And you can verify that on the bag. We got our M4 by 30 millimeters. So that's just a handy skill to have, so that if you need a specific size bolt, you know what to ask for. Instead of being like, I don't know, it's about this long. Then the store clerk gives you exactly what you want, and then you're like, well, that one's too short. I need one that's a little longer. So yeah. All right, JJ, welcome, JJ. He got an iFixit kit last year, and it's probably my favorite tool. Ooh, all right. Well, if JJ recommends it, then I might have to check that one out. Someone dropped a automatic screwdriver in the chat the other day, and I was thinking about picking up one of those. So is that iFixit kit an automatic screwdriver, like a USB powered one, or is it just a hand tool like one of these? Howdy, Luke A. Welcome to the chat. As much as Bamboo appeals to me, I think its open source Ratrig seems a better long-term option to me. Yeah, I think a lot of the Bamboo Lab printer will be reverse engineered sooner or later. So you'll have the design files and stuff eventually, but I do think it's kind of a pain that they're hiding so much of that information. Especially for people like me, I would prefer to just flash my own firmware onto it, just because I don't want proprietary stuff on my printers. Okay, so let's go to the next step. We've got, make sure I have everything here. I'll need 2 M3 by 16, 2 M3 by 25, and then 2 printed parts. So let's get those handy. Here's my box of parts. So, not sure which one I need here. Looks like this one, maybe. And this one. There we go. So, we're ready to get started. Let's see. So it wants me to take these M5s and put it into this little spot down here. Now I printed all these out on my Bamboo Lab printer on the standard profile, and I've been finding that all of these fasteners are just slightly too fat to fit into these hex nut holes, so it's been a bit of a challenge to get those to line up in there. I don't know if that's something that happens with all printers, like maybe Ratrig designs an interference fit just to make sure that everything works for you. But it's been pretty time consuming to get those set in right. So to help me out with this, I'm going to get an M5 screw and thread into that bolt. So if we can get that threaded on a little bit, now I can just pull this into place, which I think will be a little bit easier. And I'm a little concerned about doing these press fits into these parts because I'm putting these layers into stress. So basically we've got our weak point along the layer lines, and by pressing this in, I'm kind of forcing those layers apart, which I really don't like. Hopefully this doesn't break anything. If I wanted to be safe here, actually, I could use my torch to heat things up a little bit. Alright, so let's just get a little heat on there. I think I need a little more heat than that, but in any case, any amount of heat that you add to this process is going to reduce stress a little bit. There we go. It won't reduce strain, but it'll reduce stress. So we got that one in, and it looks like I've got another one just behind it. So we'll do the same thing. Oops. So I wonder if I finish this kit, will Ratrig send me a V-core? That'd be pretty sweet. Oh man. I mean, it would be sweet because seems like a really cool and fast printer, but it'll also be another probably week of assembly compared to this one, because that printer's even bigger. And just because a printer's bigger doesn't mean it's going to be harder to assemble, but just based on my Ratrig experience so far, I'm thinking it might take a while to put that one together as well. Okay, so just gotta thread this on. This one seems to just fall right into place back there. So while I was having an interference fit with most of the other bolts, this one just kind of falls right in, which may or may not be a good thing. We'll find out soon enough. Maybe I'm putting the wrong size bolt in there. No, that's M5 locking. So yeah, that's a little weird, but I think we can roll with it. Maybe I'm putting the wrong size bolt in, actually. Oh yeah, this is an M4. Okay, we want an M5. So here goes. Yep, that's fitting just like the first one. Okay. So yeah, that's the other thing about this Ratrig kit is we've got a lot of different size fasteners, and you've got to be paying attention and making sure you're putting the right size one in. The fortunate thing is that usually you've got some indicators that you're using the wrong size fastener when you get to one of those situations. So just think about things while you're putting it together, and you'll be all right. All right, and we'll just pull this one into place. All right, that's looking pretty good. Cool, that's in place now. I'm gonna check back in with the chat, see what everyone's up to. Get a Dremel, cut off the L part of the hex key. Now you won't need, oh yeah, put it in the drill. Yeah, sure. The S word being on the back is stupid. They need to find a way to implement it around the front so you don't need to turn it around. I assume that's in reference to the Bamboo Lab having the spool mount in the back. Yeah, that spool mount being in the back rather than on the side, I'd really prefer it to be on the side. That seems like it was a design group decision. Like, you know, the guys that want everything to look really nice and don't really care as much about the functionality. But, I mean, it does keep the machine looking clean and nice. So, someone got their way there. And you're always going to have to be able to access the back to some degree because of that poop chute that builds up with filament. That's just something that you have to deal with either way. So it's not the biggest deal, but it is a little annoying. And also they want you to buy the AMS, you know, get that $350 upgrade, which is basically the price of an entire 3D printer just to add that multi-material aspect to the printer, which is pretty steep. I mean, if they're selling that for $350, you got to think about like how much does that thing actually cost to build. It's probably like a $50 bill of materials or less. All right, so let's get back to this instructions set. Next thing I got to do is get those M3 by 25s. So these right here. And before I move on, I need to press these M3s into place. These are a little bit easier because I've got access to the top surface. So it looks like I just put M3s into all of these holes up here. All right. All right, so I got those in place, and then it looks like I insert these over here. Not sure what all of these are for, but I just do what I'm told. And let's see, we've got one M5 locking screw. Gotta trade out this M4 that I pulled out on accident. So one more M5 goes into this hole right here. So I'm not sure what the purpose of these screws is. These ones look like they just kind of go in here and go straight through the part. They're not really fastening anything. So these might just be to reinforce the structure, maybe. Or maybe I just need to screw them in all the way to sink those lock nuts all the way down to the bottom, and then I'll back them back out so that I can attach something else. So there we go, we've driven them all the way to the bottom, and now when I back them back out, I can probably attach something right there. All right, it's looking good. All right, and then we get our belt and just kind of loop it in here. So there's a tiny little loop right there. I'm just gonna make a loop here and pop that into place. It looks easier in the instruction manual than it does in real life. Come on. There we go. All right, just like that. So that's a nice little toolless way to install a belt, and that's holding in position pretty well. I don't know how much tension this could take before it breaks, but it seems to be doing all right. Okay, and then I've got another little piece here. Looks like a really small part. I gotta find it now. I think it's this one. So this guy goes in right like this. And then probably these two screws look like they're the right length. So we'll go ahead and attach those. And then we got one of these cross-threaded. Lovely. Ta-da. Oh no, this isn't going to be easy, is it? It's another one of those things. All right, we got both of those in place now. All right, that's pretty good now. Nice and sturdy belt connection. And that's all good, so we're moving on to the next step. So now it's time to prepare the X carriage plates. So let's get those parts handy. We got this little triangle dude. This other little triangle dude, and some little belt parts. I think it might be this one. Probably not. Probably this one. Well, let's just get them all handy. I'm really not sure what piece I need here. Maybe it's this one. Well, it'll become obvious in the next step. Hopefully it'll become obvious as I'm putting it together. There's also the possibility that I didn't print a couple of these parts out just because it's a little confusing having to deal with all those different pieces. All right, let's see. Checking on the chat. Squirrel Brain, hey there, Nathan. Running the screw through the nylock before inserting it into the part will reduce stress on the printed part. Running the screw through the nylock's nut. Oh, okay. Reduce stress. Yeah, okay, all right. So you're kind of like breaking in that nylock nut before you get started there. Not a bad idea. $350 filament wasting machine. Yeah, the bomb will be quite low. Yeah, the that AMS unit. It puts the bolts in the holes? Sure does. It doesn't put the metal parts against the screen. Well, yeah, that's fine. I can just get that screen replaced. It'll only cost like $800 because it's a locked down piece of hardware like a Bamboo Lab machine. All right, back to the instructions. So what do we have here? We're gonna assemble this thing, basically bolting that plate onto the other thing. Oh yeah, I gotta get my fasteners ready. So M3x8 cap screw. That's 2 of these. No, 6 of these, M3x8. All right, next up is the 2 M5x12 low profile. All right, I was just looking at this bag earlier, so I know they're in here. Two of those. And let's see, 2 M3 nylon locking hex nut. Where are those? All right, our nylon locking nuts bag is almost empty, but we need 2 nylon locking hex nuts. Yep, that's our last 2 M3 there. And good riddance too. I don't really like nylon locking nuts just because they're more annoying to install, but it hasn't been that bad on this printer so far. So now that we've got everything ready, time to assemble. So it looks like we attach this plate onto this part. Just like this. I think this is right. So that's where these low profile M5s go, I assume. Oh wait, upside down. We're upside down. So I want this to be like that and put this on like this. Oh, gotta flip this 180. Flip it over and we're good. All right, nice and easy. That looks good. Next step, I have to attach this little thing to the end here. So facing down We've got 2 of these screws. Of course, this would be too easy if these were clearance holes. Overall, all of the tolerances on this machine are pretty tight, and I assume they're doing that to get better strength out of these parts. I mean, you can make the holes wider to make everything easier to assemble, but you end up losing out on some strength that way, which isn't that big of a deal when you're designing metal parts, but when you're designing these plastic parts that are on the verge of breaking anyways, you definitely got to have as much material in those joints as possible. So this is just a bed wire guide, so this is, I guess, a strain relief. So it doesn't have to be all that strong, it's just got to hold those wires in place. I think they're using so many nylock nuts on this part of the machine because it's part of the bed slinger assembly. So this is going to be whipped back and forth at 10,000 millimeters per second squared acceleration. So having that extra vibration resistance is going to be a good thing. Prevent those nuts from coming loose. Alright. Okay. Okay. Of course, I have difficulty with every single step of the process. Even just putting a nut on a bolt, it's going to take me about 5 times longer than it should. For some reason, these nuts and bolts are wanting to cross thread. So it's taken me a little bit longer to make sure they get started correctly. Yeah, this is having a hard time threading onto anything. Is this like an M2 bolt they slipped in here just to mess with me? Yeah, this should be an M3. I've been having trouble with these nylock nuts that were provided with the kit. So instead of fussing around with this, I'm just going to get my own. Fortunately, I have some handy here, and they're black instead of silver, so it'll look cooler. Now let's try this. There we go, first try. So I think the nylock nuts that they provided are kind of difficult to work with. I'm going to go ahead and just replace this pair with the black ones that I have from my hardware kit. Just stuff that I have laying around the house, you know. Alright, and we'll tighten those down. we go. All right, and let's move on to the next step. It says now we need to install the Y-axis carriage. So I guess we're going to be attaching this to our little slider block now. So that's going to be a pretty big deal. We'll finally have more than one component on this frame. This is all just one solid piece right now, but we're starting to get something that looks like a printer. There's going to be some moving parts. Let's see what's going on. It doesn't put the running through the lock nut before is reducing its feature and will disregard in bad practice in my book. It'll be fine in this case though. 10 log powder coated their extruder covers after cutting the threads. Works like a lock nut on steroids. Struggled a bit there until I decided to recut them. Yeah, something that they do that I learned about when I was working in aerospace is there's lock nuts that they have where they'll actually like build the nut and then they'll like hit it with a hammer to deform the nut, and that acts like a very powerful locking feature. I'm not sure if that's exactly how they do it, but basically the threads are kind of deformed. So when you tighten it in, then it locks, and it's all metallic, so you don't have to worry about like it getting above the melting point of this nylon material that's used in the lock nuts. So it should be a lot more reliable at high temperatures, which is what you want in an airplane. Okay, so let's get this put together. According to the instructions, we've got to set it up like so, just like this, or like this. Let's see. Yeah, like this. We need these. We're going to use these small socket head cap screws. So let's just get that attached. All right, there goes the thing, and we'll screw it on there. All right, I didn't really torque these down yet, but I'm guessing it's not going to matter so much, so I'll just tighten these down now. I'm actually going to use an Allen wrench for that because you get a little better control over the torque that you're applying. With handheld tools like this, you can't really wrench on them that much. But these ones, you can just put a nice, consistent load on each one of these fasteners. It would be better to be using a torque wrench for all of these. I think that's one area where the 3D printer industry is a little barbaric. Nobody uses torque wrenches, but I think you probably should. And then according to the instructions, you got to slide it back and forth like this. That's probably very important for the assembly process, so let's just do that. Whee! Whee! All right, that's looking good. Next step, we need to run the belt. So, oh crap. I put this belt in backwards, so the threads are on the wrong side. Fortunately, this won't be too difficult to fix. Let's just zoom in here. I just gotta loosen these up and then flip it around. And fortunately, the smart folks at Ratrig decided to design this in such a way that you can access these screws, so I don't have to completely take the whole thing apart in order to redo these belts. So I'll just pull that out. I don't know if there's a better way to do this. Seems like this is a little unwieldy, but it's good enough to get the job done. And hopefully I won't have to mess with it very often. All right, there we go. And then we'll get back to the belt routing. So I just need to loop it around like this. And then it goes under. And through this. Oh yeah, let me zoom out a little bit. We gotta fish it through this little pulley. Just kind of push it along. Ooh, and you can kind of turn this pulley wheel to help you get it through to the other side. So I'm just okay. There we go. Ta-da. All right, nice and easy. Now next step, I'm not sure if I actually have this piece, but it's saying to install the Y-belt into here. Just shove it in there, I guess. And okay, and then you need to cut the belt. So basically you want to feed this in as much as possible, and then it looks like where it meets up with the 3D printed part, count 16 teeth from that point. So we're going to start right here and count out 16 teeth. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, 16 teeth out, and then we're going to cut it. Which I don't like doing, but it's a little nerve-wracking cutting this belt, because we'll be out of order for a little while if I cut this to the wrong length. But hopefully that was the right length. And then move on to the next step. Oh, it says 16 millimeters or 8 teeth. So I actually need to count back and cut off 8 more teeth there. But we'll do that when I need to. Then it looks like you take this piece and you attach it on right there. Just shove it in to this little plastic part. That's a nice fit there. This was printed on the Bamboo Lab P1P, and it fits in there real nice. And then you'll just insert this block. Insert the block. Before I do that, I want to clean up this part just a little bit. So I got my deburring tool, and I think it was printing with this side on the bottom. Or no, it was printing with this side on... One of these sides was on the bottom. But either way, I'm going to clean this up a little bit before I install it, just because it's going in there a little bit rough. So I just shaved off the corners there. Now when I install it, it should go in a little easier. Not quite. I'm going to shave off a little bit on this face here, which I think was the bottom of the part. Using my handy deburring tool. Yeah, this is looking like it's not wanting to go in super easily. Oh, wait, what? Okay, I've got something weird going on here. I don't know if I did something incorrectly here, so I've got to kind of double check the steps that I took so far. But as you can see, looking into that block, these fasteners are sticking through. These are my M5 low profile screws. These are sticking through the bottom, so when I try to insert this piece, it's running into that. So there's basically no way that's going to go in the way that it is. So I might have to cut those screws short a little bit. I'm going to go back through the instructions and see if there's any hint as to what's going on there. So let's see. We want M5 by 12 low head cap screw. Okay, I used the wrong screws here. So here's our M5 by 12 low head cap screws in the bag. Yeah, if I could read, then that would probably help. So let's get those out. But again, this is one of those cases where you've got so many different fastener sizes that it's gonna be kind of challenging to make sure you're grabbing the right one every time. So I'll just swap those fasteners out. That's not too big of a setback. All right. Need to unscrew that. So, where are my tools? Si en now gosto muito desse modelo de impressora 3D. I don't know what that means. Yep, deforming these nuts is always an option. Alrighty. Actually, I'm going to install this other one before I finish taking the second one off. That'll make my life a little bit easier. But yeah, putting together a 3D printer kit like this is nice because you get a lot of inspiration of things that you can do in your own 3D printed designs. I mean, the people who designed this printer know a lot of neat little tricks, and you can definitely leverage that in your own designs to make things as nice as possible. All right, I'm just gonna screw these M3s all the way in, just so I don't forget about them later. Uh-oh. There we go. All right, and now this should go in just fine. It's still having a little bit of trouble, but those bolts are out of the way at least. So I'm probably gonna just have to force this a little bit, and I'm also going to cut this belt back. I'm also going to cut this belt back a little bit, just because I included too many threads on here. I mean, too many belt teeth, so we'll cut off 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and we will insert this belt back into the 3D printed part. I think they had a minor design revision for this piece, so it looked a little bit different than what was shown on the instructions, but it's not that big of a deal. We can figure it out. Okay, so now that's installed, and I'll just put a bolt into this hole to kind of cinch this together, I assume. All right, so yeah, we need a long M5 by 50. So that's a pretty long bolt we're gonna install there. This is the one. So we'll just get that installed. And this is actually a pretty heavy bolt for something on a moving stage like this. So they could probably make this assembly a little bit lighter if they moved down to a smaller screw size. But what do I know? I haven't used this Allen key size yet, so I have to find something to screw this in with. Let's see, will 3/16 work? No, too big. My 5/32 is missing. Let's see if our 9/64. Nope, 9/64 is too small. Yep, that's right, everyone. This isn't a joke. We're measuring things in 64ths of an inch because that's totally a system that makes sense. All right, we've got just the right Allen key for the job. I'm not sure how much adjustment I have left in this belt, but it looks like it's pretty much bottomed out, pretty close to it. But that's fine, as long as we can get these belts tensioned, we're all good. All right, looks good to me. This is starting to look like a 3D printer. All right, that's sweet. Nice and fast. Looks like my belts aren't perfectly aligned. I gotta move this pulley back a little bit because it's currently kind of has an angle here. Let's take a look at that. So you can see when I move this back and forth, it's not great, especially when it's close like this. You can see this is at like a 1 or 2 degree angle. So we're going to push that in until this is all straight. We get everything lined up. The cool thing is if we look at these belts right here, when this is not aligned, you can see these belts aren't coincident, but as we push them together, we can get them to line up just right. And it actually looks like it's going to be better if I flip this pulley around. I don't know if I didn't follow the instructions correctly, but let me loosen this up. But if I pull this off, gotta loosen it a little more to get that off. Pull this off. Come on. There we go. And then flip the pulley around. I think I'll have a little bit better success at getting this tightened in the right spot. All right. All right, that's all good. Now we'll tighten this belt back up, and that will, I think, conclude this part of the assembly. It looks like I have to put the bed on actually as part of this step 4, so we're gonna have to keep on working on this a little bit more. Oops, I caught it that time. I think that's the first time I've caught something on stream. All right, there we go. Everything's looking pretty well lined up. Sweet. All right, next step. Prepare the bed parts. So we're going to be putting the heated bed on here as well. Not a problem. So here's the heated bed. This is a 180 watt heater, which is pretty powerful for how small this is. I think the normal heated beds on like a Ender 3 are probably like 200 watts, maybe 250. So this one's just a little bit smaller, but I think it's probably a little bit more powerful for its size. So let's get this put on there. Looks like we're gonna need basically this bed. Now this part comes with the mechanical kit, I believe, but this part doesn't. This heater bed, and it's like a custom heater bed, so you're gonna have to buy this either way, which is yet another reason why it kind of just makes sense to buy the electrical kit. Just because the mechanical kit sounds cheaper, but by the time you buy all the required parts that you're gonna need to put this together, it ends up costing quite a bit. So just getting that pre-assembled, the full kit, makes a little bit more sense in my opinion. So we've got our last little nylon lock washers. I'm going to take these two extras, these M3s that were kind of cross-threading. I'm just going to throw them away. So let's go back to looking for nuts. Ooh, sweet. We have a super chat. Hell yeah. HNG3D, thanks for the 11 euros. That's pretty sweet. I'll keep this stream going an extra hour just for you. America is slowly inching its way towards the metric system. I don't know if that's a joke, but it's a funny way to put it. Yep. I think we are actually kind of switching over to more and more metric stuff. which is pretty nice. He doesn't like the printer. Not sure what's not to like so far. It seems pretty well thought out. Oh yeah, so see, and thank you for the translation, Herzelnerk. Yeah, I mean, aside from it taking so long to put together, it seems like a really well-built machine. So as long as you like putting 3D printers together, then you're really going to enjoy this. If you don't like putting 3D printers together, then this probably isn't the right printer for you. The kit doesn't come with the hot end. Yeah, so the kit does not come with the hot end. Fortunately, I have this little Halde's red lizard hot end that they sent me a while ago. And I honestly didn't think I was going to end up using this. But it's got the right mounting pattern on the top of it to use on this, like their stock hot end configuration. So I'm just going to attach it right here. That's going to be pretty sweet. This isn't the highest performing hot end in the world, but it is bimetallic. It's got a bimetallic heat break there, and I think this is a copper block, and it's all plated. So it seems like pretty nice equipment. We'll give it a nice test, and we'll see if it's any good. But yeah, I would like to upgrade. I don't know if you can call it an upgrade, or maybe it's a side grade, but I'd like to switch it over to this Creality Spider hot end later on, just because the Spider hot end is a little bit lighter and it's using a ceramic heater core, which I like ceramic heater cores. The only thing that's a little annoying about this hot end is there's a porcelain sleeve inside of here and you can hear it rattling around. So when you're printing really fast, I can imagine this like clinking around a little bit, just like when you hear an earthquake coming and the china cabinet is shaking a little bit. It's making that kind of a noise. So, yeah, I can imagine if I turn this up to be extremely high accelerations, this would be clicking around and it'd be kind of funny. Maybe I could nickname the printer the China cabinet once I get it all printing that fast. But yeah, I'm going to be using this Halde's hot end. And I think the kit is designed around this Bondtech, what do you call this? LGX Lite. So this little combo will be my starting setup. I might upgrade it later on down the road, but I think that'll give me a nice starting point for this build. Okay, let's get back to the heated bed. So this is a little sticker back. We're going to stick it onto here. Also, I think we should take off these little protective stickers on the front and back. Let me know if that sticker pulling ASMR is coming through on the microphone. All right, so we'll flip this over and get this attached. Looks like there's only one way to put this on, and that's just like this. So I'm going to read through the instructions just because I only have really one shot at this, so I want to make sure I get it right. But yeah, I still have to find those nylock washers. Where in the world are they? Here we go. We've got 3 M4 nylock washers. Pop those out. So we've got these here. Let's see, where else? What else are we doing? 4 M4 nylon washers. That's going to be in my little washer bag. All right, here's my washer bag. So I've got our M4 washers made out of nylon. We get 6 of them out. All right, 6 of those, and we'll put everything in here, back in. Oh wait, but we're gonna use these 3 stainless steel spacers, so we'll keep those out. And what else do we got? 3 M4 countersunk screws, also known as flathead cap screws. So need 3 of these. All right, let's see if I'm missing anything. I think I've got it all. So we are ready to proceed with the instructions. All right, and one thing you'll notice is just working with all these fasteners, the black oxide coating kind of gets on your hands. And just taking a look at these dirty bags, these dirty bolt sacks, and these, they're just kind of dirty. So you definitely don't want to be doing this on the kitchen table. Either an office table or a garage or something will be ideal for this assembly. Now we're finally to the step where we're attaching the heated bed. So we'll just put this sticker on. Doesn't seem like it should be that hard. Now when I was a kid, we would always have Lego sets where you had to put stickers on the Legos. And it was a big deal to have the honor of putting the sticker on, because you had to be precise and you only have one shot, because you're not going to be able to peel those stickers off without ruining everything. So hopefully that experience has qualified me to install this here sticker. Oh no. Oh no, I'm off by 0.5 millimeter. Oof. I think it's probably going to be better if you align this based on the overall pad dimensions, but then again, you want to be relatively close here. This is pretty good. Well, it's not going to be perfect, but this is a big conductive plate, so if you're off a little bit, it probably won't matter. But this is one of the fun parts of putting your own printer together. You gotta be meticulous about things and have it be as accurate as you want it to be, or as accurate as you have the patience to get it. Okay. Oh man. These are high stakes operations. All right, I think we're ready to finalize this. Now, any type of sticker, if you're referring to them in an industrial or engineering context, they're referred to as pressure-sensitive adhesives. And they're called pressure-sensitive adhesives because their bond strength is kind of correlated to how hard you press down on them or how much pressure you apply. So if you just kind of set this in place, the sticker might just pop right off. But if you go over it with like a rolling pin, they have these little rolling devices that really press the stickers down onto the parts. That's when you really get them to bond strongly. So I'm going to use this piece as a little rolling pin kind of thing, and I'm just going to press the sticker on. And now that we're doing this, this sticker is not going to want to move after this step. And this middle area, I'll just kind of press on to get it to stick. Then I'll go over the edges again just to make sure it's all stuck on there. And I first became aware of this pressure-sensitive adhesive kind of idea in the automotive industry. So as you might know, a lot of things nowadays are held in place with glue and stickers. And you'd have issues on the production line when people didn't use the rollers to really press the adhesives into place, and they would just come right off. But now you can see this sticker is really stuck on there, and it's not going to move, because you have to have that step where you really mash those surfaces together. If you don't, there's really no way to visually tell that it's not installed correctly, but you'll be able to pull it right off. So that's all done. Hopefully I didn't mess that up. Man, I'm always nervous about this kind of stuff because I may or may not have messed it up, and I just don't know. I don't think there was a wrong way to install this. I hope there wasn't a wrong way to install it, at least. Yeah, it looks like this is correct. So we got the wire coming out towards the front, and that's what it looks like on their official documentation. Over here you can see it, so that's all good. All right, just checking in with the chat again. So always wash your hands before putting stickers on if you've been handling greasy nut sacks. I mean oxide-coated bolt bags. Yeah, well, I mean, thanks for that comment, Jellyfinger. It's really reminded me that I should read these things in my head before I read them out loud. So you should have stuck with the screws and stuck the screws and spacers on first. Yeah, that would have made sense, but we're past the point of no return. We're just going with it now. So next step. It's time to put the spacers on. One spacer on each corner, and then one nylon washer. And then after that, okay. So a spacer and then nylon washer. I think we can handle this. So spacer. I'll move this to the back so I'll have access to the bottom side of that one. So one spacer on each one. One nylon. And then all right, then I gotta take this. We'll drop a fastener in each hole and then just kind of line it up and install it. All right, here we go. Nice and easy. And then on the underside, we're gonna put one nylon washer and then the nylock nut. So I guess I can tip this up a little bit and things will be all right. Oof, yeah, I don't want to tip that too much, so we'll just go this far. I'll use one of these Meanwell power supplies as a standoff, and then I'll start putting these together. Ta-da! Oh, I don't think I got an answer yesterday of which was better, Voron or Ratrig. From what I've heard, I have no personal experience with this, but from what I've heard, the Vorons are a little bit easier to put together. They've spent a little bit more time making sure they're using common fastener types on the whole build. And this one, we've got all these little fringe fasteners for all these different parts. I think it's fine to use the wrong, it's fine to oversize the fasteners if it means you're going to save time in the long run with assembly. Like if you just make a blanket decision to only use M3s and M5s, then I think you can end up saving a lot of time that way. Because for any application where you could use an M6, you could instead use two M5s and probably get the same result. Which would increase your overall fastener count, but it would decrease the number and type, decrease the type of fasteners, number of unique fasteners. So I think that actually makes assembly easier despite having more fasteners overall. You just have to spend less time looking for the right tool to screw everything in. All right, now we gotta just tighten these down. Da, da, da. And this step is gonna take a little while because we're just screwing in these nylock nuts. We got my handy dandy Knipex wrench pliers. These are some of my favorite tools. And notably missing on this printer are is that we don't have any bed leveling springs. This is a rigid mounted bed, just like what you got on the Prusa. And I think, honestly, that's the way that 3D printing should be going in. When you have bed springs, it's actually kind of hurts your ability to print fast because those springs are going to be bouncing around at high accelerations. So if you can get rid of those springs, you're going to increase your ability to print quickly, which is a good thing. And also, it's just 3 less things for people to have to manually work on and calibrate on their printer just to get it working reliably. I mean, I think we've got enough printers out there with no bed leveling springs that have proven that you don't really need them. All right, so there we go. Looks like things are a little bit wonky, so I'm gonna straighten it out. Let's just go like this. Yeah, I need to loosen these screws up a little bit because it's bothering me how this isn't perfectly aligned. That's another thing that kind of bothers me about the Bamboo Lab machines is if you look at any time-lapse videos or any videos of them doing high-speed printing, you'll notice that the Z-axis is constantly moving and like moving up and down to account for the warpiness of the bed because you lack the ability to calibrate that yourself. You just have to let the software compensate for it, which sure it probably does a fine job of, but I just like getting everything as mechanically perfect as possible and then having software correct for any leftover deviance, any leftover deviation, rather than just having software correct for everything And then you've got this z-axis that's always having to be hyperactive to account for just a small misalignment from the factory. Foron seems like they're aiming for a refined and polished end product. Ratrig seems like overkill and strength was the main design criteria. Both good, just different. All right, yeah, that sounds good to me. This is like brute force engineering, using massively overspec'd linear rails and aluminum extrusions to make up for the fact that the frame shape isn't ideal for strength. I mean, those cube frames have a lot of advantages in terms of the rigidity of the whole machine, in terms of the structural efficiency, but you can always make up for that structural insufficiency by just making everything bigger and thicker and heavier. So yeah, that appears to be Ratrig's approach. So this is all ready. That's looking pretty good. I don't actually have a bed surface for this yet, so unfortunately I'm just going to be getting my fingerprints all over this thing as I continue to work on it, but that's just too bad. Yeah, that'll be fine. I would like to put a PEI sheet on here. I don't think I have one handy, so that's a bit of a bummer. So here's what I'll do. We'll just, I can't unwrap this sticker very easily, but we're gonna try. Yeah, I'll get to the cable strain relief in a minute here. I'm just, you know, I'm just gonna have to wipe this down when I'm done with it and ready to put a sticker on, because I'm gonna get grease all over this thing. So I shouldn't have peeled that off just yet, but it's fine the way it is. All right, so next step, let's see what's going on. Cable strain relief. King Sidorak must be following along on the online instruction manual. So let's tuck that in there. I'll just, let's see. Prepare the print surface. Yeah, I don't think mine came with a PEI sheet. So that's kind of, you know, you're buying the mechanical kit, it's extremely stripped down, so you're missing some components that you're probably gonna need to get started with the printing. So that's a little unfortunate that that is missing, but we're just gonna have to deal with it for now. I mean, we don't really need the print surface until we actually start printing stuff, so it's not the end of the world. And I guess if you want to be technical, you can get away with just putting some blue painter's tape down and printing on that, but I don't really like that. Okay. I believe if you get the full kit for this printer, it should come with a PEI print surface, because the instructions are talking about it like you should have one. But I do not have one in the mechanical kit. I'm probably running this cabling wrong anyways, so instead of looping this through that hole, I'm just gonna, well, I'll just kind of loop it through this hole and then wrap it around here. So I'm just kind of trying to get it out of the way so I can still move things around and print. And we'll come back to this when we get to the wiring portion, which is going to be really fun, according to all the comments yesterday. Wiring is where it really gets interesting with this build. Okay, so those cables are out of the way and we're ready to move on with the build. So y-axis end stop, I think I'm gonna just skip that. Someone in the chat correct me if I'm wrong, but I've got these TMC why don't you just take a look there. We got a TMC 2209. So I believe I should be able to set up automatic homing, like sensorless homing with that print thingy. So in that case, I won't need these y-axis end stops, so I'm just going to skip it. Also, since I didn't get the electrical kit, it doesn't come with those end stops. So yeah, we're just going to have to go on to the next step. So now we're ready for x-axis assembly. Looks pretty sweet. Let's get on with it. So we're going to need this thing, this thing, three 2020 M5 square nuts. They're around here somewhere. Here we go. Square 2020 M5s. I thought they would be bigger. That's why I was having trouble finding them. So these are all M5s. I used up all the M6s, so I'm just going to take all of these out of the bag since I don't have anything to mix those up with anymore. And we're going to be using 3 of them here, so I'll take 3 of them and set them up front. All right, and then 2 M3 nylon locking hex nuts. I've had just about enough of the nylon locking hex nuts that were provided with the kit, so at least the M3s, the M3 ones were kind of cross-threading a little bit, so I've got a couple extras here, and I'll add to my kit. 2 drop-in T-nuts M5 for the 2020 size. All right. That's right here. So drop-in T-nuts 2020 M5. All right, so we got 2 of those. And 4 M3x8. M3x8 right here. Just get 4 of them. And 5 M5x10. No M5x10s in here. M5x10 cap head screws. All right. Here they are. No, never mind. M5x12. M5x10. All right, here we go. The text is a little faded on there, but we got them. So 5 of those. And what else do we have? X gantry end cap printed part. All right, I've got some of those too. So I printed this one out a couple of times. It looks like, let's see, one of them was printed out with 2 perimeters, and I was like, oh, I need to print that out with more perimeters according to the Ratrig instructions. I think they want you to print your parts out with 4 perimeters is their recommendation. But I just made this one with 2 perimeters. And then I printed this one out again, and I accidentally oriented it the wrong way, so it's pretty messed up. The Bamboo Lab P1P was able to print this, but it needed some support, or it needed to be oriented in a different way to actually come out right. So we'll just throw that one away. And we're using this 2 perimeter cap, which is kind of unfortunate. That really should be a 4 perimeter part. But I am not gonna slow this build down now. We just gotta keep going with it. So it looks like we mount this little T-shaped plate to our Z-axis. So we'll get started with that. Here we go. All right, and let's see. Jellyfinger, you're welcome. Oh yeah, thank you for the reminder. Good evening all. Thank you 3D Puck for joining. Are you telling me that the effing laptop mic is the mic being used? I don't know. Could you hear it? Like, oh, yeah, maybe the laptop mic is the one being used. Let me tap on my laptop. And then if I tap on the, if I tap on the real mic on my camera, it's idle. So let me go ahead and add my audio from the external mic. Man, changing stream settings live on stream. This is tough. Streaming ain't easy. Okay, let's see. Let's see. Oh, I need to add a new audio input capture. And we'll go with the camera. And now, there we go. So I'm going to turn down the desktop audio. Mute that. I'm going to mute my laptop. And now we're capturing audio with my fancy microphone. It's not that fancy. I'll try and show you on camera. It's this guy right here. The Rode Video Mic Pro. Video Micro. Let me know if the audio is any better or worse. But we're just gonna go on that now. So that means you must have missed out on that sticker pulling ASMR earlier, because I was holding that up to the microphone up on the camera. So sorry for that. I know you're all really looking forward to that. But next sticker, I promise I'm going to capture in maximum detail. So, all right, now that we've got this... Sorry for putting metal on the laptop. It probably sounds like I was directly setting them on top of your eardrums. So now that my mic is all set up, what do you think? Should I turn the gain down? Is it okay? I can turn the gain down a little bit if it's too loud. But I'll check back in on your opinions as this is an ongoing issue. But I'm going to start putting this x-axis on over here as well. So let's see what we need to do here. But yeah, I was using the MacBooks. This is a MacBook Pro, and I'm using the microphone on that. I use it for a lot of things, but it's actually quite good. But maybe you would have a better judge on how good the audio quality was. I wasn't forced to listen to it for the last 4 or 5 hours. Okay, so we're gonna put this on here. We've got our little M3s over here. So here's our hardware pile. right there. Ta-da. That's all the parts we're going to be using. And we're just going to be putting it together here. So here goes nothing. Yep, Mr. Ed, I'm continuing with this build. If it's the last thing I do, it's well, that'd be unfortunate. But we're getting it put together. Alright, so back to the instructions. If the carriage binds at all, loosen the M3 screws and check again. Okay. So, gotta put this on. Pretty simple operation here. But now that the microphone on the camera is active, you're going to hear it whenever I mess with the camera. It'll be all boom, 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 boom. Okay, we're building this thing. So while you're all here and I have an audience to get some feedback from, what do you think I could do to improve my stream quality? You want some nice little subtle clubbing music going on in the background? You want some classical? You can find some no copyright sound music to play. Do you think that would help? All right, that's looking pretty good. Next step is to get some of these. And this is pretty simple. I think if you've put together one of the classic Ender 3s, the idea of having one of these the idea of putting together one of these kit printers is a lot less daunting. But if you're just coming from like pre-assembled printers, and you'd have to be learning how all this stuff works basically as you go, I think you'd have a little bit harder time putting something like this together. But at the end of the day, it's not too difficult. Now, one thing that does bug me a little bit is once I install this piece, I'm not going to have access to these M3 screws anymore. So I need to make sure these are torqued down before I proceed with the build. So I'm just going to get all these M3s torqued down. I would prefer to have access to these screws after this assembly is complete, because being able to loosen these up and adjust things seems like it would be pretty nice. But there isn't a whole lot of float in this joint. Like normally I'll want to have access to screws so I can loosen all of them and kind of do a little micro adjustment and then tighten everything back down. But in this case, since there's barely any float in this joint as is, it's not that big of a deal that I don't have access to it. But yeah, alright, let's get that tightened. Oops, that was loud. And you don't want to overdo it on these M3 screws. They're not very strong. Alright, there we go. And now let's put this aluminum extrusion on. Alright, hello Mr. Kmet and AMAC. Would be good to have a known time for the streaming. I only saw your streaming after 30 minutes. Yeah, that's true. I could announce it a little bit earlier. Xenon G, no music is fine. Alright. Do you want some random printers going on in the background to give you something to look at? Maybe just like have a little corner of the screen down here where I've got like a time lapse or something, or a live feed of my my Ender 5 S1, which is I think idle right now, but you know, we could just let some prints run. All right, this seems like it's pretty good right here. I'll tighten that down. Now later on I might want to loosen those 3 bolts up just to get this square, but for now this is good enough. And this is pretty funny. It's like a little traffic gate thing. Like, oh, you blocking everything and then moving up out of the way. That's great. So next step. I kind of jumped the gun here and just put this on, but apparently this is exactly how I was supposed to do it, so looks good to me. Now we'll put that X-axis end cap on. So we're down here. Just got to hammer these into place. Let's see, I've got just the tool for the job. Where are my tools? I thought I had just the right tool for this, which would be a first for this build. Here we go. Yeah, I'll take this, kind of insert it like that, and we'll pop that into place. See, I just load it up like so. Just boom, and then put that in there, and then pop it into place. That's pretty good. Okay, so that's done. Then we need to take these M5s, put them in the top and the bottom. And this is one of the parts that really should be printed out with a lot of perimeters, because this is going to be taking some structural loads, carrying the tension from the belt. But unfortunately, I did not print it out with multiple layers. So we'll see how 2 perimeters does. The nice thing about this is it's at the end, like it's over here mounted on the side of the machine, so it should be pretty easy to access it for repairs if I need to. And I think we'll be fine. So we'll kind of set that in. Oh, that goes over here actually. I think that goes... I'm just trying to reference this picture and get everything right. So I'll flip the printer back around, get that same perspective. And let's see. Just like this. And then I'll tighten these screws down. No problem. Ooh, yeah, that's a really bad... the way that I've printed this out is really bad, because we've got 2 layers of external perimeters, and then infill, and then another 2 layers of external perimeters. So this part that I'm clamping down against could very easily break and crack. So that's something I'm definitely going to want to replace on this machine after I get it running. I'm planning on doing quite a few upgrades to this machine later on, so I don't have too much of an issue leaving it like this for now, but that's something I'm definitely going to have to work on a little later. Alright. Wow, and that's all the parts. I used up all my hardware I had sitting there, so we must be ready for the next step. We're going to the Z-axis lead screw and cable management. So here's our Z-axis lead screw. Got our little cable management piece. And then 2 M5 by 15 low profile nuts. Those are the ones I accidentally installed on the Y-axis, so I have those handy. What else do we got? 2 M3 by 12 cap screws. M3 by 8. Let's see. M3 by 6. It would be nice if all of these fasteners came in like one of these little boxes with dividers. That'd be a lot easier to keep track of everything. But since we got all these individual bags, I'm ending up spending a lot of time just kind of going back and forth between bags, reading the labels on them. Not the best user experience, but it's certainly getting the job done. M3 by 12. I think that they might have been in another bag that I emptied out earlier. Oh yeah, here's the M3 by 12s. They're empty, so I think I found them. They're just kind of sitting here. And if we measure these, yeah, that's 12. So we need 2 of those. We've got the lead screw, drop nuts, low profile thing, anti-backlash, nut block right here. I guess the last part would be an I mean, it should have a little fastener in there, according to that diagram, but I don't see that. Don't see that anywhere, but we'll just figure that out later. So, let's get started with this step of the build. This thing's starting to look more complicated. Let's flip it around. And so we're going to take this, that's just a grub screw. I think I found that. M4 grub screw, M4 nut. Okay, yeah, I have those. So that's these 2 right here. And install the grub screw and then put the nut on top. That's a pretty strange little piece of hardware there, but we can do that. So here's the part. I'm just going to install this grub screw. Da-da-da. So install the M4 grub screw into the anti-backlash nut block as shown. Stop turning the grub screw when it touches the bottom part of the nut block. Okay, I can do that. Then secure the grub screw by installing the M4 nut. Alright, pretty weird setup there, but we're going to go with it. So here it is now. We got our grub screw. And the nut. So kind of a weird thing, but I just do what I'm told. Now we're going to install the Z-axis lead screw. So let's get to it. Ta-da! Alright, what's my favorite printer from AMAC? Oof, that's a tough question. I think I don't really know of a perfect printer at this point in time. I think if you look at different use cases, there are printers that are better than other printers. in certain use cases. I think the Bamboo Lab P1P is the easiest printer to use. So if you just want something, or Bamboo Lab and Prusa are pretty similar in that they're companies that have really focused in on the whole user experience. So consequentially, they have some of the easiest printers to use, in my opinion. If you like modding things, I really like the Ender series of printers. Just because they've been using the same kind of V-groove wheel setup and linear extrude, the V-groove linear extrusion for all the major components of the machine. And they have an enormous market share. So just naturally you end up with a lot of people designing and selling mods for that printer, that myself included. But also if you look at companies like MicroSwiss and like tons of other companies, they make mods specifically for the Ender series of printers. And as good as... I gotta plug in my battery, 1 second. And as good as Prusa and Bamboo Lab printers are, like they're pretty amazing printers when it comes down to it, and super easy to use. But as good as they are coming in at a price point that's just like way above what you'd get for something like a Creality machine. So I think they could really work on producing some lower end entries into the market, maybe making them maybe pretty cheaply built printers, but also provide a really good all-inclusive user experience. I think that would be a good development for the 3D printing world. So yeah, I think Ender 3 or similar cheap machine if you just want to get started in the hobby and don't want to spend a lot of money. If you want something that's just going to work from day one, either a pre-assembled Prusa or a Bamboo Lab machine could be pretty good for you. But I think it's good to have competition in the market, so I just want all of these printer brands to succeed and produce printers at different price points and for different use cases. I think that's going to be good for everyone. Okay, so back to the assembly. Looks like I need... this is getting complicated. So we want our low profile screws here. We'll drop both of those in. And then we need some drop-in M5 T-nuts. I don't think I prepared those. Maybe I misread the instructions. I don't think they mentioned it. Drop-in M5 T-nuts. If I scroll up, yeah, it actually did ask me to get those ready, so here they are. Another brand that I think could be pretty interesting is Kiditech. I reviewed their X-Max printer, which I thought was kind of overpriced for what it was. It's a huge, heavy machine with a nice sized printer, nice sized print area, fully enclosed, heated build chamber, a super solid bed for you to put your prints down onto. But the issue with it was kind of slow and it was kind of locked down and not super open source. So they're releasing some new printers that are supposed to run Clipper and get very similar performance to Bamboo Lab printers. They're basically benchmarked against them. So I think those printers could be pretty good, but it just really depends. I need to see some reviews on them before I really have too much of an opinion on them. All right, so let's see. So the whole point of this process is to get this bolted down so that it's lined up with the stepper motor right beneath it. So we'll go ahead and install this lead screw So let's get this lined up. Need to loosen up this coupler a little bit. It's already loosened up. Just got to tap it in a little bit. Okay, and then we'll tighten that down. And then we'll get this aligned as best as possible. So we can adjust this coupler up here, left and right. So I'm gonna basically, I'm gonna try and get this as straight as possible. And I can see I've got a little bit of Z-screw wobble, but I don't think that's that big of a deal. I think this lead screw is a little bent, which is kind of unfortunate. But due to this really strong linear rail that we've got for our Z-axis, I think that's going to compensate for any kind of Z-screw wobble that we have. So I'm not going to make too big of a deal about that. We'll just get this thing put together. And yeah, I'm just kind of aligning this by eye. All right. And that's lined up pretty good, and then we'll tighten this into place. Uh-oh, I just moved it. All right, let's get that tightened down now. So hopefully that's pretty good. But yeah, CNC Kitchen recently did a video about the Bamboo Lab and how apparently he did some testing. You'll have to go check the video out yourself to confirm all of this, but I think he did some testing and it showed that the Bamboo Lab machine the prints coming off of it were quite a bit weaker because of their high-speed profiles. They're not melting the filament sufficiently, so you're getting poor interlayer bonding. And that's something that I was, I'm pretty mechanically apt, so just from printing some parts out on that machine and breaking them apart by hand, I could tell that they were significantly weaker than some of the prints, than basically all the prints that I do on my other printers. So you're getting speed, but that's coming at a price, and if you're sacrificing strength for speed, that's a really bad trade-off in my book. Like, you should always be trying to get your prints to be as strong as possible. Because if you're designing things in a mechanical perspective, and you're basically designing things to be a certain level of strength, then if you're losing 50% of your strength just to have speed printing, then you have to make your parts twice as thick to compensate. So then, you're just using more plastic for a part that's heavier and not as strong. So I think the priority for me has always been to make parts that are as strong as possible, because I'm not out there printing Dratinis or Pikachus. I'm trying to make parts that are useful. My channel name is Nathan Builds Robots because originally I was printing out stuff out of 3D printed, PLA, and I'm making robots and stuff out of it. Things that need to withstand certain levels of force. So yeah, I'm always really got a critical eye at machines that are producing parts that look good but aren't any good in terms of mechanical strength. Alright, AMAC, cool. I have an Ender 3S1 Pro, although in hindsight I think the Elegoo Neptune 3 Max may have been a better deal. Yeah, I mean, I've heard a lot of things about the Neptune 3 series. I've asked them to get one in for review, because a lot of times I hear people talking about, oh, this is the best printer ever. It's just an Ender 3, but cheaper and better in every way. But then I get my hands on it and I use it, and I'm like, you know, this is just as bad as an Ender 3. Like, this isn't really any better. So, I don't think you can really judge a printer until you've actually seen it. And the unfortunate marketplace that we're in today, everybody's buying their printers online. So by the time you've had it delivered to your house, you've paid for it. And then you can't really be like, oh, this isn't really living up to expectations. Then you have to box it back up and ship it back. But anyways, yeah, I got the SV06 in for review because everybody's saying, oh, that's a Prusa i3 MK3S, but for a third of the price. I mean, it looks like a Prusa i3 MK3S, but in my experience, it wasn't nearly as good in terms of print quality and speed. So there's just these little attention to details things that are really important when it comes to the overall function of a printer, but you can't really assess that until you've got the printer in front of you to see. So I'll be releasing my SV06 review. To me, I think it's basically, they took the best parts of the Prusa i3 MK3S design and combined that with the worst parts of an Ender 3, which is lower build quality, and really bad part cooling and some other things. So make sure to subscribe and check back in once I've released that video. It should be out probably next week. Okay, let's get back to the build. Bamboo Lab P1P or Ultimaker S3. I'd probably go with the P1P. Unless you're doing government or proprietary work, then I'd go with the Ultimaker S3. They've been around a little bit longer, and I mean, I don't know anything about the company, but I would tend to believe that they have a little bit better handle on security. Up the temp and increase fan speeds for better fan shroud designs. Yeah, that will work to some extent. I think, yeah, if you up the print temperature and increase fan speeds, like really what you need to get two layers to bond effectively is to have them both up to the melting temperature of the material, especially at that interface between the layers. You want that to be heated up to the point where they're both melted and they fuse together. I mean, think about injection molding. You're basically getting the same materials as the bulk plastic. You're not really losing any strength because everything's molten and everything's cooling down all at once. With 3D printing, you're never going to get that because by definition, the previous layer is solid, and then you're laying a molten layer down on top of it. So you might actually be able to get better adhesion if you have like a tiny little heat gun that's preheating the surface before you lay down the plastic on top of it. That could be a way to really boost the layer adhesion. There's all sorts of things that you could do to improve the process, but right now we're kind of, despite these printers seeming fast and seeming like they're pretty good, we're kind of still in the caveman era when it comes to 3D printing. All right, so back to the build. We have got the next step here. Align the Z-axis lead screw. All right, I got to align it front to back as well, so let me do that. I think I need to bring this stepper motor back just a quarter of a millimeter. So let me unscrew these. We assembled this part of it yesterday, but basically this whole Z-axis stepper motor is attached to these little slots. So I can loosen them up and slide it a little bit. Got a little bit of adjustment front to back. Alright, that looks pretty good to me, and we'll tighten it back up. Now, a lot of people are going to complain about things being manually aligned and lined up by eye, but a lot of things can get done by lining things up by eye. I mean, take a look at some iron sights on an old rifle. You can hit a target out, you know, to 300 meters plus using iron sights, and that's just aligning things by eye. So, don't discount the power of by-eye manual alignment. Alright, so this is all tightened up. And this is all pretty good. Alright, that's fun stuff. They've got a little guidance here on how to get that alignment done. But what I've been doing is I'm basically moving my point of view until I've got the lead screw. I've got the gap of this lead screw lined up so that it's visually touching this corner of the extrusion. So you can see that gap is just barely there. All right, now it's basically touching. Then you look from top to bottom, and when that's lined up from this perspective, that should be pretty darn close to perfectly straight. And if you want to do another visual check, you can line it up with the other corner there. So line it up just like this, and now if you look at the left edge of the lead screw and the right edge of this extrusion, you can see that's pretty much perfectly aligned all along the length of it. And that's going to be good enough for me. So now it's time to install the X-axis wire holder. Let's get that in place. So should be pretty easy. I don't have my wires yet, but let's install this wire holder. So that just goes in. We got our 2 screws handy. Oops. And then we'll screw these in. Crap. Did I forget to put some stuff in there? I think I need to run these in without that cable in place, and by tightening these up, it's just gonna pull those nuts all the way to this edge. So internally we're just like pulling that nut up to this close surface, and that'll make it so we can install that other piece. I find it interesting that on this kit they're not using any 3D printed plastic as a material to thread things into it. In a lot of my designs, I'll just print something out with a 0.27 millimeter hole, and then you can thread an M3 screw directly into the plastic. And for low stress applications, it works great. And even for higher stress applications, just increase the depth of that thread engagement. For instance, if you're threading into a solid inch of plastic, you're going to get really good clamping force out of that. Despite the plastic not being very strong, just by doubling or tripling or multiplying by 10 the amount of material that you're threading into, you're increasing the strength of that joint. And it saves a lot of time and reduces fastener count, so I think it's a totally valid hack, and it's one that I think more people should use. Alright, we got our little Y-axis holder here. So this is one application where I think you could actually get away with just threading directly into the plastic. And if anything, you just make this a little bit thicker, the part that you're threading into, so you got more thread engagement. This is a really low stress application, so I think you could get away with it. But anyways, it's time to move on to the next step. I think it's a little odd that they're showing this little part here. I do not have that part installed onto the printer yet. I don't know if that's my fault or if that's something I'm going to have to put on later. But yeah, so let's go down to this part, and we're going to need to pull some more parts out. So we're going to need a stepper motor. This is one of my, I went over this at the start of the stream, but basically I salvaged a bunch of my old printers. I pulled off the old extruder motors on them, and I'm using them for this application. So just basic Creality extruder stepper motors for all of the motion systems on this printer. We'll see how it works out. Apparently there's a lot that goes into stepper motor selection, but I'm just going with some big old basic Creality motors, and we'll see if they're any good. And it'll be nice that the nice thing is I'll be able to upgrade those later and see if that actually improves print speed or anything. Like, are LDO motors really worth it? Well, I'll be able to make a video comparing before and after on this printer, so that'll be pretty fun. Alright, let's get our hardware ready. So, looks like I'm going to need this thing. We're going to need... we're going to need this. There we go. I'm going to need this X-axis belt pulley. Let's see, we're going to need that stepper motor. We got it. 3 M5 T square nuts. So 3 of these. Oh, that's 4. We need 3. 3 M5 by 10 cap screws. That's right here. We'll pull 3 of them out. And finally, 4 M3 by 8 cap screws. So use the M3 by 8 cap screws. We'll just pull 4 of those out. Alright, and I think with that we are ready to begin this step of the assembly. So we're just going to be bolting this on. Interesting. Wow. Oh, that is weird. Oh, okay. Okay. Alright, the way that it looks on this assembly, it looks like they were going to just bolt this on to the very far end of this cantilevered little extrusion. But you've slide it on. I think it ends up being over here close to the stepper motor, which makes a lot more sense mechanically speaking. You don't want your heavy weights being way out here on the end. But hold on, while we're checking this thing out, this thing is like very sturdy. Like, look at this. It barely wobbles at all. And if I push on this, it starts to move, but that's because it's picking the whole printer up and moving it. That's a very sturdy little printer here. So I guess we'll start putting this together. So I'm gonna go check in with the chat here, see what's going on. But what if you have a perfect first layer? King Sidorak is posting a link to another YouTube channel. That's a bannable offense, but he's a mod, so I don't think I can ban him. That's pretty unfortunate. Layer adhesion issue. Can you just print hotter? No, cooling is an issue, and cooling is an issue as well there. Yeah. I think one of the ideal solutions is to print in a heated enclosure. Even for PLA, just having that part preheated means that you're going to be able to melt that interface layer a little bit better. Bamboo Lab P1P. P1P is cheaper. Ultimaker S3 is an enclosed printer. It's pricey. Maybe compare it to the X1C instead. Yeah, I don't know anything about the Ultimaker lineup. I've seen them before, like when I was in industry and academia, I saw a couple Ultimaker printers, but they seemed really expensive. X1C, I mean, X1C is probably better value and possibly higher performance, but that whole cloud thing I'm just really not comfortable with, especially if you're in a company where you're developing proprietary hardware. You definitely don't want to be just handing that over on a platter and giving it to Bamboo Lab. S3 can print metal. Okay, possibly. Technically, any 3D printer can print metal using a process similar to metal injection molding. So, I mean, I'd love to do a little video about that process because it's really interesting. When I was getting my master's degree, I knew some people that were working on on 3D printing with a really similar process to metal injection molding. Basically, you get metal-filled filament, and you lay that down, and you end up with a part like this, but it's got like 30% metal filings built into it. Then you put that in an oven and heat it up and cook off all of the plastic. So all of that plastic boils off, and you're left with just this sparse structure that's just a bunch of metal filings that are just loosely bonded together. Then you heat that up even more to the point where those metal filings basically melt together, and you continue to heat it up, and it actually shrinks because it's like densifying itself. It's becoming more and more dense, and it shrinks down, and eventually you end up with a part that's like half the size, but it's like a solid metal part. It's a really cool process, and it's one that I'd like to experiment with, but given all of the challenges with that process, it's something that is unlikely to be seen in like a hobbyist use case for a little while. I mean, I'm sure it'll be a thing in the future, and there's expensive machines that you can buy that do it now. But in terms of it trickling down into into people that want to spend less than $20,000 on a printer setup, I don't think it's going to be practical for a little while. Just to give you some examples of parts that I suspect are made with metal injection molding. One of the best examples are these little iPhone plugs, little iPhone plug adapter. Let me zoom in on this so you can see this little part. I think these are made with metal injection molding, and also these press fit pulley wheels, probably also made with metal injection molding. And kind of the hallmark of a metal injection molded part is usually they use that process for parts with very complex geometry. That would be really expensive to machine. Like, this is a metal part that's got really complex geometry. But also, you'll have finer details than what you can achieve with die casting. So this is a part that was made with die casting, most likely. So made out of a giant metal mold, and you dump liquid metal into it and cool it off and pop it out. So it's just like injection molding, but it's done with metal. But metal injection molding refers to that process where you start with a metal powder filled plastic. They call it a binder material. So it just binds the metal powder together. Squish it in there, then you have a plasticky metal-y part. Then you cook it until it shrinks down into the final form, which is a solid metal part. But enough about that fun stuff. Let's get back to building this printer. But what if you have a perfect first layer? Yeah, perfect first layer. Check out the podcast. It's on Apple Podcasts now, so fun stuff. It's great for if you're on a long drive or a commute or whatever. Just kill some time listening to people talk about 3D printers. You can only achieve that with the new MK4. Oh yeah, that's true. They invented the perfect first layer. Joking aside, getting a trouble-free first layer is already 50% of the way for a good first print. Yeah, getting that perfect first layer, that's extremely important. And I'm going to talk about this in a future video, but I think the load cell-based calibration is much better than our BL Touch or even these inductive probes. Because with these inductive probes, you can get repeatability down to like 0.01 of a millimeter, like extremely accurate, but you're relying on a human in the loop to calibrate that device. So if there's some way to get the human out of the loop, that's always going to be better, because we are not very accurate in terms of our ability to measure very fine, very small distances. But anyways, I think we got to put this thing together now, so let's get to it. Integza made a video on 3D printing metal. Yeah, that's pretty cool. Yeah. All right. So yeah, and the beacon, the CR Touch, these inductive probes, they all have the same issue where you can measure the location, but you need to then relate that to the nozzle location. And if you had a precision machined tool head and precision machined nozzles, you would know the exact spacing between the bed leveling probe and the tip of the nozzle, and then you wouldn't have to do that stupid little Z offset calibration. But everything with 3D printers is extremely imprecise, and it's something that I think manufacturers really need to work on. Manufacturers and designers. All right, see you later, AMAC. Thanks for joining the stream. He's probably going to go watch that Integza video again. Seems pretty excited about that. Okay, so let's get to the build. This is coming off of an old Ender 3 style extruder, so I got to take this off. Remove the brass drive gear thingy. Remove this tape. I'll make sure I have all the equipment for this step. I think I have all of it. The funny thing is you drop, we're attaching this like this, but you have to drop these screws like way down into the hatch. They go way down into the bottom, just through this hole. So we'll push all those down into the holes there. Ooh. All right. Well, they actually don't even, oops. Okay, I'm just pushing those screws in because I think I'm going to need them there anyways. But it says it wants you to attach them to this thing first. So we'll get this attached here. We're going to use these M5 screws and these little T-slot nuts. I think Prusa has really proved out that you can make a reliable printer out of 3D printed parts, which is pretty cool. But I mean, the future of these printers has to be going to more precision, having things be built more precise and out of better and less expensive materials and processes. So that's just my 2 cents. All right, so we're going to take this and it gets installed. I find the easiest way to make sure you install it correctly is to match the perspective of the drawing. So we want this thing like this, just like that. All these different Allen wrench screws are getting pretty annoying here. What would be great is if someone invented a tool that automatically produced the right Allen wrench size. You just hold it up near a screw and it's like, oh, I know what size that is. Let's deploy the correct Allen wrench. So if any of you crazy inventors out there need an idea on something to design, there you go. This is not the best experience. Not a huge fan of these nuts that you have to align both sides and slide them in at the same time. They could have made this a little bit easier if they made it so basically instead of having these two in line with each other, if you offset this one by half the distance between these two, so it's like right in the middle, then you could line up the bottom one, slide it in, then line up this one, slide it in, then line up that one, slide it in. But the way that they have it right now, you have to align the top and the bottom at the exact same time, which is much easier to do if you have 3 hands, which I don't. So, oh my gosh. So they must have hired that 3-handed dude to do this kind of stuff. Maybe they had a 3-handed design engineer on the team. It's like, oh yeah, you got this, bro, no problem. Just, there we go. All right. Then I think we're going to slide this all the way to the back. Oh, what? Yeah. Yeah, I'm doing this. I think I'm doing this right. Okay, and then we're going to attach the stepper motor with the wires pointing up. All right. Let's keep this going. I haven't thought about the end time of the stream yet, but I think I'll probably be able to finish most of the assembly today. I think a nice clean break point would be when I get to the electrical assembly. I'll just give myself a little break. And maybe take some time to organize all my electrical parts and make sure I have everything on hand before I get started with that. Okay, so just gonna keep on going here. And then we'll slide that down. So, according to the instructions, you slide it pretty much all the way down. I'm not going to butt it up against this, I'm not going to butt it all the way up against this coupler because that would hamper my ability to adjust that left and right to align it with the stepper motor. So I'm going to leave like a millimeter of gap there. I'm not sure if that's the right thing to do, but it makes sense for me to do. I think it says push the assembly all the way along the x-axis for the moment. Whatever that means. So it doesn't say to tighten the M5x10 screws yet. Now we've got to put our final linear rail on here. So we'll take this piece and get it slapped on there. Looks like we're going to need 10 M3 by 8 cap head screws. I think I have those around here somewhere. M3 by 8. Let's do this. M3 by 8. Yeah, here we go. M3 by 8s. We'll get 10 of those. And then we're going to need those T-slot nuts, the drop-in variety. Where are they? I need to really organize my workspace next time I do one of these streams. Just have like little spots for each one of the fasteners. That'd be pretty sweet. But we've got M3s. We need 10 of them. I think that's everything that's in this bag by the look of things. So Here's our 10 M3 bolts. We got 5 here and 5 here. Okay, so 10 drop-in T-nuts. That's all good. Alright, I'm getting some a napkin here just because this thing is greasy as heck. Alright, so that's all ready. And we're gonna just slap it on here just like that. So we'll just get it, put it on just like this. And just looking at the instructions. Oh wait, nope, it goes on the top actually. So it goes on just like so. That's nice and easy. We got gravity on our side today. So this will be pretty similar to our Y and Z axes that we did yesterday. So it shouldn't be much of a problem. Oh, okay. Yeah, I'm going to check on the chat here. So Jay Cannon asked before, but I think you missed it. Are those high-wind rails? And if not, do you think paying twice for high-wind rails is worth it? Well, let's take a look. I'll go to the Ratrig website and see what's included in that kit. Oh, this is the Dozuki website, so let me pull up the Ratrig website real quick and we'll take a look. Alright, so here's the Ratrig V-Minion configurable kit. I think I got the configurable kit, but it's just the mechanical. So includes the frame, bed plate, mounting hardware, and all the motion hardware. You need to add electronics. I would, after going through this process, I would probably recommend getting the full kit and then just pulling parts off of it if you don't like them. The octopus seems like a little bit of overkill here because you're only driving 4 stepper motors. So I don't know. It might be good to do the mechanical kit and just, you really got to spend some time speccing things out if you want to do it that way. But let's see, linear rail based motion system. I'm not sure what linear rails they're using here. I don't think they're high winds. Open builds. Nah. Bargain B stock. Linear rails. Okay. Let's take a look here. So linear rails, yeah, they don't specify the maker of these. I'm guessing they have a trusted supplier for these bad boys and they just get them in. For this build, we're using MGN 15 and MGN 12. So it looks like these are on sale right now, so 18 euros, not too bad. That's actually a pretty good price. If these are high quality as far as I can tell. Like, just check these out. They're like, whee! Oops, don't want to drop that. But yeah, these rails are pretty decent quality. So they're not bargain basement rails is what it comes down to. So, you know, they might not be high winds. I don't even know if high winds are worth it. I have no real knowledge or experience with them. But yeah, the other issue is if you're buying high wind rails off of AliExpress, are you actually getting high wind rails? It's a real head scratcher there. So I would be inclined to just go with the rails that come with the kit because they seem pretty nice. I have no complaints with these so far. They seem to be nice and sturdy. I haven't had any real problems with them, and they seem to be decent quality. So to answer your question, I don't know what they are, but they're probably not high winds. And I don't really think paying double for high winds is worth it. You just need to get some decent linear rails that are good enough. We're not dealing with like super precise measurements here, and these might wear out over time. I mean, they might get rusty spots or whatever. You might have to replace them. So I would tend not to pay like twice the price for high winds. What's up? Hey, Rice Bear, welcome. Rafael Novo, there's no linear rails for X. Yeah, there's linear rails for X. This is the X-axis right here. I'm already hyped. Well, the funny thing is that this is actually a V-groove extrusion. So I could put a Sprite hot end, just get a Sprite hot end kit and mount it onto this V-groove extrusion. But that would be, I think, blasphemy to use linear rails for everything else and then use a crappy rail system for the X-axis. We're going with the linear rails. Hey Namion, welcome, welcome. Namion, I think you've earned your wings today, so I'm gonna add you as a moderator. So thanks for being active on the Discord and joining us for the stream today. Rails need to be lubed. I found a really good way to do it if anyone is interested. I should be stripping the grease off and putting proper grease in the sled? Yeah, probably. You need to clean and lub rails regularly, but it's not as much hassle as replacing wheels in my opinion. Alright, alright. So, Rice Bear, I think not cleaning and lubing the rails is going to haunt me later. Well, we'll see. We will see. I mean, they came in these bags. I could show you the bags, but I think I threw them all away. Let's see. Nope, I got one here. I mean, they came in these bags, and they seem to be pretty well greased. But yeah, if it ends up haunting me later, you feel free to tell me I told you so. You think they're going to run dry? All right. I actually don't have a lot of experience with linear rails, so this is all good information for me to have. I will keep it in mind as we move forward. But for now, the build must go on, so we're just going to put this together. So, just putting all these screws in place here. Man, there's a lot of these little screws. All right. That shipping gunk is just a thin layer of rust protection? Okay. Alright, well if there's a quick and easy way to lube these up, then I'll be interested in doing it. But I may be incorrect here, but I'm thinking I'll be able to just do it with the machine assembled. And if I can't, then that's a huge pain, and I'm going to complain about it. I've never had such an issue with V-groove wheels, so say what you want about V-groove wheels, but they seem to be mechanically a lot simpler, and you're dealing with sealed bearings versus these. These are, I mean, technically these are sealed bearings because they have wipers that keep the, that wipe down the surface as the block moves back and forth, but they are much more open to the elements than V-groove wheels. Or the other way to think about it is V-groove wheels are a lot more tolerant to little dust and debris than these are. Like, I wouldn't want to print with this thing out in the open desert. Man, it would be nice if Ratrig had a way of delivering these with all of these T-nuts pre-threaded, But that would be taking away all the fun of putting this thing together. Or, even better, instead of using aluminum extrusion for this part, if you just machined a, if you just had a machined hollow box tube frame here, and then you drilled and tapped holes directly into a steel hollow shape, or an I-beam shape or whatever, that would be a lot less labor intensive and a lot less fasteners for me to put in at this phase of the assembly. So take that for what it's worth. All right, almost done here. All right, I got that all installed. You mean use the grease port? Oh yeah, I think there is a grease port on these. It looks like there's little Allen grub screw holes on here. I guess they hold this thing together. I haven't really gotten into the whole linear rail thing, but I'm going to be learning more about it. And this machine's a big reason for that. If anyone bothers to send me a Voron kit to put together, I will do it and learn even more. So let's go back to the instructions here. We're all the way down here. So, all right, we attach that. It says, do not allow the linear rail to leave at the end of the rail. Okay. I'm guessing that that's a bad thing if you let this slide off the edge. So I'm not going to do that. So it says loosely thread to each of the, slot it into place. Do not fasten any of the screws yet. Okay, you got it. So next up, we're going to get this little piece put together. I was just looking at it earlier, so I know I printed it out. Here we go. Okay, so I'm going to use the last 4 of my T-slot M5 square nuts. Three M5 by 10. Okay. 3 M5 by 10, so these guys. All right. 1 M5 by 25. That's in here. M5 by 25. 2 micro precision shims. Let's see. It's always satisfying with these builds. Once you empty out one of these bags, you can just throw it away. And that's just makes things nice. This one's empty also. We're going to throw that one away. Because then there's less bags for you to have to look through when you're trying to find the parts. It's like, I don't know if it's solitaire or some other game where you slowly narrow things down. Okay, so here's our two shims. We'll put those down over here. And we want this little idler. So that's everything there. I think we're ready to start putting this together again. So here goes nothing. Preview of the instructions. Looks like we're just inserting a bunch of things into this little guy and then putting it onto the end of the printer here, just kind of like as an end cap, just like so. So let's get started with that. All right, and if Nipex is watching, please sponsor my channel and send me all of the great tools that you have. I will gladly accept your free tools. So Raised Bear asked LDO for a 2.4 or Trident kit. I would love that if they would send one over for me to review. I had kind of an awkward interaction with the Jason from LDO. He's like kind of the founder or something. I don't know what his role is in the company. But I asked him what the point is of buying an LDO motor because all my stepper motors on my Ender 3s work just fine. So I think he was kind of taken aback by that statement or question because he was like, dude, I don't even know where to start with that. Like, I guess it was too basic of a question for him, and he didn't want to go down to the fundamentals of stepper motor design just so he can answer a question for one guy at a convention show. But I've done some research on stepper motor design, and I totally get why specifying the right motors is very important to get a high-performance machine. So another thing that I'd like to talk to LDO about is these stepper motors. These are just the basic steppers off of an Ender 5 or off of an Ender 3 extruder. So they're the Creality 42-40 stepper motors. I'd be really interested to see if I replace these stepper motors, these basic Creality ones, with some of their high-end stepper motors, how much is that going to increase my print speed and quality? So I think that would be a good advertisement to show off or showcase the capabilities of their products and just kind of put some numbers to it instead of just being like, oh, these stepper motors are better. All right, so I got to insert this little idler into that hole and put spacers on either side of it. So let's do that. I think I gotta use gravity. Gotta work with gravity this time. So I'll put this down here. Come on, there we go. Oh. All right, got that one. We'll push this one in. And then we got to jam one of these little shims into position. And that's where these little tiny pliers come in handy. All right, we get that into position. Then using our really thin tool, I don't know if you're going to be able to see this. All right, then using a really thin tool, we'll just kind of poke it until we get it into the right spot. And then there we go. Ta-da. All right, you didn't see that, but there we go. It's all good now. So, I'll just put these square nuts on. Oh my, and this is, I was just complaining about having to line 2 of these up at the same time. Now it looks like I'm going to have to align 4 of them at the same time to get this end cap put on. But yeah, we'll get to that. See how difficult it ends up being. Okay, so Namion says it's as easy as taking the sled off and cleaning everything with rubbing alcohol and re-greasing it. Well, I mean, I don't know about you, but that sounds like something I don't want to do. So we'll see how it works without going through that whole process. I may or may not have dove head first into them when I got my Gulf Coast rail kit. Yeah. Good evening, Nathan. Good evening, everyone. Thank you for joining Britallion Chap. It's we've got a interesting little process going on here. Megan Fox thumbs making progress. I see. Yes. Yes. Thank you. So we'll get this put together. All right, and just like this, we have we got all 4 of these in place, and then we just gotta slide that on to the end here. So I'm not excited about this. I gotta line all 4 of these up and get this slotted into place. But here goes nothing. I have a feeling this is going to take a little while to get everything all lined up here. But that's what we got the chat here to keep me company while I do it. Or if we've got any tips or advice on how to make this easier, that would be fantastic as well. All right, now we gotta get this top one. Oh, there we go. That was not as hard as I thought it was gonna be. So for what you're doing with the build, it should be fine, but before extended use, I'd clean and grease them. All right. Namion always giving advice on preventative maintenance. All right, and flight instruction lesson for my son is finally done. You make quite some progress when I was away. Flight instruction lesson? Is your boy flying? Is he flying through the air? Got any KY jelly? I don't think that's the right type of lube for this application. Yeah, I mean, I'm surprised how far I've gotten to. I mean, yesterday took a little bit more time. I think there was a lot more fasteners and just looking for bags. Since I had like 20 bags to dig through whenever I had to find a fastener, it took longer. But now I'm down to a lot less bags. So when I need to find a fastener, it goes a little bit faster. It's good stuff. Okay, so let's see what we got to do here. I just need to tighten up these 4 screws, I believe. But I'm going to go to the instructions just to make sure I'm doing everything in the right order. Oh, okay. So they actually have some advice on getting all 4 of those aligned at the same time. They want you to put 2 of them in and then slide these 2 in from the side and then put the screws in. I just did it all 4 of them at once, which didn't end up being too difficult. Now it says fasten all 3. Okay. So it says to fasten these ones and then fasten that one. And they got a lot of warnings here, so I'll heed those warnings. It says don't over tighten. Check that the tooth idler rotates without binding. Okay, take care not to over tighten. Got it. And all of that needs to be done while ensuring that this is pushed all the way onto the part, which it looks like it is. So we'll go ahead and get our fastening on. All right, and last one over here. All right, and we'll see if our little idler is spinning freely, and it sure is. So we're all good. I'm just inspecting all of those T-slot nuts to make sure they're seated properly, and it looks like they are. One thing that Ratrig could do to make this a little bit easier to do is add oh shoot, you guys were... Okay. One thing Ratrig could do to make it a little bit easier to inspect those T-slot nuts is add a little viewing port here, so you can kind of like poke tools in there to get them oriented the right way. But overall, it really wasn't too difficult, so I'm ready to move on to the next step. It's all good. Align and secure the X-axis linear rail. That's our next step here. So let's do that. Looks like I need to make sure the rail is centered. All right. So it's not providing any dimensions. I'm just going to use my calipers to make sure that the spacing is equal on the front and back side. And I'll do that measurement in 4 locations. So should be pretty easy. It should, oh, it says it should be 4 millimeters at all points. So we'll see about that. Looks like they want me to butt the rail up against this part on the left side. So we got that there. And I'm a lot less worried about this going off the end of the rail now, so I'm going to pop off that last end stop protector. Ooh, that is... Now we're in a bit of a pickle here because I don't see any way for me to insert these last drop-in T-slot nuts here. These ones, I can get one in here on the side pretty easily, but getting it into position is going to be tough. So this is my own fault. Now I'm kind of going to have to figure out how to do this in a tricky way. So, all right. Looks like there's just enough room to pop this in here, but I just dropped it in and it went in upside down, so we gotta finagle it around a little bit. Oh, there we go. We got it in right. Now I've got to poke it to move it down a little bit. Get it in position, and then I'll put the screw in place. So I'm a bit of an expert in putting things together incorrectly. So despite not following the order of operations, I was able to just kind of barely get this to work. Alright, there we go. And we'll do a similar thing for the other side. So we'll push that back. Over here we've got just enough of a gap to drop this nut in here. I don't know if this is going to work either, but where there's a will, there's a way. We're going to get it. Oh, there it goes. Now I've got to flip that over. All right. Here we go. Got it flipped up the right way. Then I just got to push it into position. And we're good. All right, I'm going to check back in with chat just to see if anything's going on here. Well, I've got this very interesting process going on. All right. He didn't deny having any. Yeah. I don't know. Lol. Does your kit come with a Pi? I don't think so. I think what I'm going to do instead of using a Pi, well, I haven't decided yet. We'll make that decision when I get to the electrical assembly. But I've got this FL Sun thingy here. It's like a Sonic pad, but from FL Sun. So we'll see how that works. I do have a Pi handy, so I can throw that on there if I want to. Honestly, that might be the best choice, but I'll have to make that call once. It'll probably be the last decision I make on this machine after I get all the electrical guts put together. Then I'm just deciding how to control it. I can just slap on whatever I need there. Wait, is he using proper wrenches today? Well, I mean, they're kind of proper. I'm using, let's see, my set of wrenches here. We've got Imperial inch-based wrenches. We've got our 9/64ths, which is sure to trigger a lot of metric people. 9/64ths of an inch. Do you know what that is in millimeters? Real quick. Okay. Then we got our 50 milli-inches wrench over here because we ran out of fractions to use. I mean, I guess the next one in this logical series would be, I don't know what you would put there. Maybe 7/28ths of an inch. I don't know. So, yeah. Anyways, I'm using inch-based wrenches on metric fasteners, which is an interesting choice. But I don't have my I don't have my set of metric wrenches anymore, so we're just making do with what we have. All right, so time to get these measured and bolted into place here. I guess the exact location of this doesn't matter that much. I think I'm going to butt it up against this side. So get that as close over there as I can. Then on my calipers, I'll set this to 5 inches. No, 5 millimeters. And then we'll bump that up against the thing. Now that does not seem right. It says to center it on this rail, but if I use 5 millimeters, it's definitely pushing it off to one side. So, I mean, let's just do some measurements here. Oh, no, it's supposed to be 4 millimeters. My bad. So, go to 4 millimeters. Yep, that's pretty dead on. So 4 millimeters it is. I'm not going to bother measuring both sides. I'm just going to measure it off of one edge because, you know, that's how mechanical stuff works. So we'll get this here. Tighten that into place and then move over to this side. Get that gap set. All right, here we go. Now you're tightening these T-slot nuts blind, so you don't know if they're rotated correctly and engaging as they should. But you just gotta trust that it's gonna all work out. So far, every T-slot nut that I've tightened on this machine has like auto-rotated and got into position just like they're supposed to. So I have a tendency to believe that most of these are probably being attached correctly. And one thing you can do to make sure that you get the best chance is unscrew them all the way and then screw them in. So, hey Nathan, did the Prusa MK4 worth the wait or too little too late after Bamboo Labs? I would kind of avoid comparing those two machines. I think they're, well, I mean, I won't avoid comparing them, but they're not designed for the same kind of user. The MK3, the MK4 is, I like it a lot more in the sense that it's much more open source. You can probably flash your own firmware on there. And it's more moddable and maintainable. So one thing that I have serious concerns about is with that P1P, the Bamboo Lab P1P and the X1 Carbon. Are any of them gonna be still operational in 2 years? Because none of the linear bearings can be maintained, and when you're printing a kilogram of filament, you end up traveling like multiple kilometers on your rails. So those will wear down, and especially when you've got those carbon fiber rails that are sliding against graphite-lined brass bushings. I have no idea how long those are going to last, or if they're just going to fall apart. So it remains to be seen how many hours you can rack up on a Bamboo Lab printer before it quits, but the lack of maintainability is one thing that I'd be pretty concerned about. XY jelly, that's pretty good. Mike Jones is saying someone should make a printer lube called XY jelly. But what about the Z-axis? The Z-axis needs some loving too. Alright, this fastener here feels a little odd, so I think it wasn't seating properly. I'm going to go back in, loosen it up, and then retighten it. This is kind of an issue with T-slot nuts. I really don't like them. They're not a great solution for this stuff, but hey. I wouldn't have minded using those squared off T-slot nuts for this axis and just sliding them all in from the side here. I think I'd have a lot more peace of mind knowing that the fasteners would be tightened down correctly. But that's why you've got 10 of these fasteners, so if 2 or 3 of them aren't good, then the slack will be carried by the other fasteners that are in parallel. Alright, that's all good now. Whee! People will mix up the two variants. I don't know what we're talking about. Does FL Sun Sonic Pad thing run vanilla Clipper? Apparently the Creality Sonic Pad is heavily skinned and kind of locked down. Yeah, so I think it's using its own version of Clipper. That'd be really nice if they opened... I don't know if these are open source devices, if you can just flash your own custom hardware on there, or custom firmware. That would be really great, like if you could just install Linux on there and run them that way. As far as I know, you can do pretty much everything you can with normal Clipper. Ask Nameon for more. Yeah, on the Sonic Pad, to run Input Shaper, according to Clipper documentation, you type in input shaper axis equals X or whatever in the console and press enter. But they disabled that console command on the clipper, on the Sonic pad. So you have to go through the menu and go through the touchscreen and say input shaper, I'm running this for this printer. So it's a little more annoying because it doesn't match up exactly with what the clipper commands are and the clipper documentation. I think the less you mess with clipper, the better, because that's a pretty darn well-engineered piece of software in its stock configuration. So, I mean, it is what it is. But yeah, the more we talk about this, the more I'm thinking I'll probably just install a Raspberry Pi. This is going to be my electronics case, and I think we've got a spot to bolt a Raspberry Pi into it. And this is going to be hanging off the back right side of the printer so that I don't have to have a separate little assembly just for my electronics box. And that's the way that Ratrig has this set up. If you look at Ratrig's website, 3D printers, Ratrig kits. If you look at their stock build, I mean, it looks nice right here. There's no electronics here. But then you go to this picture and it's like, oh yeah, you have to have this stupid little box off to the side, which I think is a big no-no for me. Like, if you're going to make a printer, just integrate everything onto the printer. There's no point in having a separate box like this. So I'll be doing my best to incorporate everything onto this device just because that's the kind of workflow I want to have. I don't want to be juggling multiple pieces whenever I have to move this printer around. Because really one of the advantages of this printer is its portability. But if you break it into two parts, then you have to have like this clutch full of, power brick, this other box, and all the cables connecting them. That's going to be annoying. Okay, so let's get to the next step of this process. We've got our X-axis rail installed. Now it's time for us to move on to, let's see, to securing the X-axis motor. So, flip this around. I love how sturdy this thing is still. It feels like a very solid machine. This feels super solid. Okay, now time to bolt this in place. So let's get our handy little Allen wrench here. It says push the X-axis as shown, so it wants me to butt this up against the, wow, it like slides over the top of that. Let's zoom in so you can get a close look there. So it says to push it as shown, like this, and it slides over the top of this rail, which is kind of interesting. So now there's a pretty significant gap between the stepper motor here and the this nut, this anti-backlash nut. So we'll get that tightened down, and don't want to over tighten these since we're just attaching them to a 3D printed plastic component. Alright, so that's locked in place now. Cool. Next step. Prepare the Z-axis cap ports. Okay. For some reason, I'm not sure if I printed these out. So, yeah. I do not know why I avoided printing these, but I'm going to have to print those out a little later. That's just a cap that goes on the top of this Z-axis, so it's not going to be important for the rest of the build. So I'm just going to keep on going with my Y-axis assembly. I mean, I'm hoping it's not important for the rest of the build. Yeah, it really shouldn't affect anything. Cool. I haven't put the belt on or anything, so we'll get to that next. Spool holder assembly. This is one of the things that in the review from ModBot I saw he was complaining about this, how it's all these different pieces Yeah, that is a little ridiculous how many parts they have just for a spool holder. As far as I'm concerned, you could just print this out of a solid piece and call it good. But I guess one of the cool things about this is it looks like it should be extremely sturdy because you're holding it on with these large extrusions and stuff. So you can probably use this as a handle, and that'll keep you from touching the linear rails. Like if you're picking it up like this, you'd be touching that linear rail and the belts and stuff. But having this off to the side, this little handle you can pick it up by, that'll be pretty nice. So let's get this put together. I like how these don't have time required filled out on them yet. It would be nice to see what kind of times we've been getting on putting this together. But let's go ahead and put this thing together here. So we're going to need this thing, little end cap, these two unique brackets. I mean, they could easily reduce their bill of materials just by getting rid of these two parts. But, you know what, I'm not going to complain about it too much. That's the decision they made, and it's not that big of a deal. So, alright. Oh, wow, that's a lot of parts. Okay, so apparently I was supposed to print 2 of these out, and I only printed 1, because one of the complaints I have about this kit is they don't give you a lot of instructions on how to print this stuff out. Like if you go to this, if you go to the documentation, step 0 should be printing. So I would really have liked to have seen some instructions on how to slice and print these files, as well as like parts counts for each individual piece. Like apparently I needed 2 of these, but I didn't see that information anywhere. So, I mean, that's a minor complaint. That is one of the things that was kind of daunting about this project is I went to the installation guides and I'm like, all right, I want to print these parts out. How do I print these parts out? And it doesn't tell you. So that's something that I think they could work on in terms of documentation. But let's keep on going here. I guess I'm getting progressively grumpier as I go through this build because now I'm complaining a lot. All right, so back to the spool holder assembly. We're gonna need all this hardware. So, 3030 M6 drop-in nuts. That's these. Gonna need 4. Oh, that's cool. I was thinking I needed some kind of magnetic parts tray to keep track of my parts, but they've got one built into the MacBook. So I can just drop all my parts right there. Alright, flat. We want some flathead screws. That's these 4 right here. Alright. One of the things that I really like about this MacBook is, compared to my other laptops, I have a Windows laptop that I use sometimes, and if I get any magnets near the Windows laptop, it'll think that the laptop is closed and it'll go to the like the sleep screen. But with this MacBook, I'm pretty sure they have magnets in both sides. So it's really hard to get a false trigger here because if I accidentally brush a magnet up against both sides, then it'll go to sleep. But as it is, it doesn't really have an issue with that compared to my Windows laptop. But anyways, enough about the MacBook superiority over the wimpy PC machines that are out there. We don't need to start a PC versus Mac war right now. Let's see. Gotta find some fasteners here. 2 cast brackets. That's these. 3D printed part, aluminum thing. What else do we need? I need 2 of these, but I only have 1 for now. Not a big deal. All right. 2 M5 by 10. 2 M5 by 10, that's right here. And 2 3030, 2 M5 3030 drop-in T-nut. All right, I'm going to try and find those. I think that's right here maybe. Let's see if these M5s thread into them. Yep. All right, so I've got everything. Time to put this together. This should be one of the easier steps in this build, just because it's, I mean, there's not a whole lot of mechanical complexity here. It's just parts bolted together. Let's check back in with the chat. Sonic Pad can do all the basic functions. I think we talked about that already. I built my V-Minion about 8 months ago. Such a fun build. I use mine almost every day. That's great to hear, Cody. I'm hoping that this will be one of my go-to printers. I mean, it certainly looks like a fun machine. The only downside that I can see is for me, since I film a lot of the stuff that I print, having a bed slinger is a little annoying because everything looks blurry on time lapses. But it seems to be super solidly built. Like, I mean, this thing is not moving at all. It's sturdier than most non-cantilever printers out there. So the fact that they're able to get such rigidity and strength out of this kind of design, pretty impressive. Yeah, thanks to Anycubic releasing the source for their firmware, a community firmware has been released, adding Clipper features and UI improvements. Just installed it. Also the bed mesh points. Although you can argue Bamboo is making the best firmware it can, and it doesn't need a community improvements, it's still nice to be able to see yourself. Yeah, that's the other issue, is that if they've got hidden firmware, you don't know what kind of creepy spyware might be going on in there. I just have a hard time trusting a company that's breaking with the norm of the industry, which has been to just open source and release everything. It's a little bit selfish. It really gives you the sense that they're trying to dominate the 3D printer market instead of being yet another participant in it. They're trying to shut people down. And I think that would be a really bad thing if all the 3D printers were Bamboo Lab printers. Like, you don't want such centralized control of things. What do I think of the Creality K1 series? Any ideas on what they're going to do? That's a great question. I should be getting one of the K1s in to review on the channel. So I will be checking it out firsthand and seeing what it's good for. I honestly hope they make a great product, because Creality is one of the big players in the 3D printer industry, and having them up their quality standards across the board would be an amazing thing. However, I'm not holding my breath, because I know a lot of their products are designed and built in a rather compressed product development cycle. Like, it seemed like Bamboo Lab had probably been working on their design for months, if not years, probably close to a year by the looks of things, like just the level of complexity and stuff. Versus Creality, it seems like they try to crank out a new model every other month. So, you know, are they spending like 2 or 3 months developing these things? If that's the case, then you're not going to get the most sophisticated or well-polished designs. So I hope it delivers on the promise of being a true Bamboo Lab P1P competitor, but I'm not holding my breath. That said, tune back in about a week. I should have a K1 in my hands, and I'll be able to show you everything about it and see if it's any good. All right. I think Bamboo has its place in the market. It's not for me, but it's closer to what a normal consumer would want. Yeah, I'd completely agree with that. They're kind of trying to leapfrog the market and tap into that, like, every person has a 3D printer kind of thing. But a lot of us that know how 3D printers work and know how to build and maintain them and want to use them a lot, and like care about the nuances of exactly what hot end or what kind of features you have on there, I think it's going to be better for people to just stick with a home-built machine. That's just going to be more fun. Alright, so I do want to get as far as I can with this build before I have to quit for the day. So I'm going to get back to assembling this thing. I mean, I don't really care about this component. It's just a spool holder. Nothing fancy going on here. I'm looking forward to putting this X-axis tool head together. So this is like you gotta finish your broccoli before you can have dessert. I don't know if that's a saying in any other countries, but that's something we say here in the States about, you know, how much we hate eating healthy food. So yeah. This is a little painful to put together because when I tighten this down, it wants to rotate a little bit. So getting everything put together exactly square is proving to be a little more difficult. But yeah, kind of along the topic of industry developments, I'm really glad to see Prusa come out with the MK4. I think that an update to that design is well overdue, and seeing them with a competitive high-speed printer is a great thing for everyone, I think. It was basically impossible to recommend the i3 MK3S because it was so outdated. But I think this new MK4 is really what they needed to do in terms of staying relevant in the market of 3D printers today. All right, here we go. Now this is kind of an interesting choice. I think this material might wear down over time as the spool is like rolling around on it, but we'll see how it holds up. I'm missing this front end cap because I didn't print one out, but that'll be easy enough to slap on after the fact. So for now we're just gonna attach this and call it good. Also, what do you think of my clear PETG color scheme here? I think it looks pretty sterile and cool. I like just using raw plastics. I don't really like all the colors and shit that they put in filament, because a lot of those colors might be toxic or carcinogenic, and you don't know. A lot of it's made in China, so it's like, are they following the same kind of safety guidelines that Western companies have to follow? It's probably going to be better if you just use as few chemicals as possible. So just the raw base material, that's what I'm going for. It's like organic 3D printing. You know, you pay extra for organic, right? Free range filament. Okay, so I don't know if this is the right spot to place this. We'll see how it works out. It should be easy enough to move it later if it's an issue. All right, so yep, that can work as a handle. It's pretty cool. That's awesome. All right, so that step's done. That was like one of the shortest steps of this process. So we'll go back. We're done with that. Now we're doing the EVA assembly, and then we'll get to electronics and wiring. So That's where we're going to have to take a breather before we tackle that part. But let's go ahead and get this EVA assembled. EVA, if you play Kerbal Space Program, means something different, but we'll see what they mean by EVA here. It'd be nice if they explained it, because I've never heard the hot end referred to as an EVA. Extravehicular activity. I'm going to check in with the chat, see how it's all going. Let's see. They took, yeah, here you can see we've got 18 viewers. Hello, 18 people. Let's see. They took our firmwares. Yep. They can take our lives, but they can never take our firmwares. What do you think about the Creality K1? Also, it's gotta say it's so ridiculous that we have to worry about privacy / ethics / rights in the 3D printing industry. Yeah. What are those brands of red and blue handled pliers? Oh yeah, you mean my Knipex pliers? Look at this. I'm like a total Knipex fanboy here. And then I've got this. This is Chinese ripoff. That's I didn't understand the color scheme until now, but it really looks like they're trying to copy a certain brand, doesn't it? I mean, that's like pretty darn close. But these are crimpers. I don't think Knipex makes electrical crimpers. I'm missing my water pipe pliers, and also I have some other mini Knipex stuff that's just really fun to play around with. But I like my Knipex stuff. Someone recommended them to me about a year ago, and I've just been buying everything I can from them whenever I need to. They took our firmwares. I wish the engineers who designed these printers made a YouTube channel and explained their reasons and choices. Yeah, that would be fun. I could actually reach out and see if they could do an interview. A lot of them aren't native English speakers. Like, I guess Ratrig is based in Portugal or something. Let me read. Well, it doesn't say here, but I think they're Spanish or Portuguese. Yeah. So it would be fun to just chat with them and interview and ask them about certain design choices. I don't think they want to be grilled on like, hey, why did you make this 6 parts instead of 1? But maybe they would like answering it. Let's see. They would receive too much backlash? Yeah, probably. I mean, the comment section would just be filled with lots of people that are like, hey, my printer isn't working. Why don't you respond to me? Bamboo takes all the fun out of 3D printing. It did for me at least. It just works almost too well, which is boring. Yep, that's for sure. I'd like to do some more kind of project-based videos, and I'm kind of, I don't know, it would be convenient to just print everything on the Bamboo Lab, but I think I'm going to stick to my more handmade machines just because I like them more. They're just more fun. You got a little bit more of an emotional connection with the device versus the Bamboo Lab printer. I mean, I think it's kind of ironic that someone designed a companion cube skin for their Bamboo Lab printer, because it's exactly like what you see in that game in Portal. The companion cube is like a robot's idea of what it wants you to have and something that you can be friends with. But at the end of the day, the companion cube is just something that a computer made for you to try and make you happy. That's kind of like what a P1P is. It's like, here, have this thing. You should like it. Here, just accept it into your life. But it's never going to be as true of a companion as something like this, where you went through the hours of building it and really getting to know how every single piece works. Rotate, like buckles that rotate. We don't talk about rotating buckles on this channel, so we'll move on to the next topic. I consider the MK4 over the P1P. I see Prusa more the Apple of printers, taking care of the small details. Bamboo is like Android when they first came out. Impressive specs. Well, yeah, I would view them both as kind of being analogous to Apple. They're just offering a much easier experience to most people. I'd consider this kind of stuff to be more like Android, where it's like, yeah, install whatever you want on here. You want an SD card? You want to change out your SD card? Put extra storage in? Sure, go ahead. You don't have to get locked into an ecosystem and buy upgrades through them, which is kind of the Apple mantra. Bamboo Labs is Apple, bruh? Possibly. Put that end cap on the other side of the extrusions if you only have one at the moment. You know, oh, geez. I'm just realizing I almost have a clash here. I think I actually do. This part is rubbing up against the block here. So I think I'll do that. Good advice. I know it's going to bother you to just be looking at this open-ended extrusion for this entire stream, so I'll go ahead and move that to the front. All right. But let's get on with the build. Let's see. Time to put this EVA together. But I do want to read through the rest of the comments before we get there. So, white is usually hard to print due to them using titanium oxide to color it. Okay. Nice. Good to know. Strange as I see them is the exact opposite. Apple has a lockdown atmosphere that doesn't allow customization, the same as Bamboo, while Android allows and encourages it like Prusa and other companies. Yeah, Prusa is open source and highly repairable. Those are some good points. I agree with you on that. Are you doing the EVA 3 or 2.4? I have no idea. This is just what I found when I printed it out. Maybe you'll be able to figure it out just based on looking at it. I got one of these type of hot ends. I think it's like designed around the Dragon style mount. So we'll see soon enough. I know there's another version of this that is designed around the Fadis BMG hot end, but I don't really like that one. I did a whole video on it a long time ago, the Dragonfly BMG or something. I'm going to go with this one and then upgrade it to something completely different when I have the time. The companion cube has feelings and you're hurting them. Oh, I'm sorry. I'm sorry, P1P. Why don't you just... it probably has a microphone and ears on it too. Oops. I'm just kidding. I don't know what's going on with that printer. Have you thought about doing a 0G Mercury 1 conversion on the Ender 5? Possibly. I don't really see myself changing the Ender 5 much more than it's already configured. I really like the way I have mine set up right now, and I've sunk enough time into it already, so I'm just going to leave it as is for now. If I want a Core XY, I guess the K1 that Creality's coming out with next week should be Core XY, so I'll play around with that, and that'll get my Core XY fix for the day. I'd get an X1C over either because I think it's a good buy. P1P is too stripped down, and Prusa, although good, is expensive, and you can get something near the same quality for less than half the price. Yeah, Prusa has never really been the most competitive on price to performance. However, with this new MK4, they're getting a little bit better. One thing about Prusa and virtually every 3D printer company now that's like producing high-end products is they're making custom main boards. I really don't like that. Recently, I reviewed the Flying Bear Ghost 6, and that one has Robin Mark IV mainboard, like I forget what it's called, but it's basically an open source mainboard, and seeing stuff like that is great to see because we don't need custom mainboards for all these machines. They're all doing the same thing. They're heating up 2 different things, and they're controlling 3 or 4 stepper motors. Like, we don't need to have a custom solution for every single one when they're all solving the same problem. Think about it, another fan for the X1, X1C, P1P, they're way too loud. Yeah, I'm definitely planning on some P1P mods. I want to get that thing printing as quietly as possible. I'm thinking about getting some automotive grade laminated glass that you get on like windshields and cars that really help reduce road noise. So I think I could get one to be really quiet. It'd be a really fun project. To push back, Prusa is moving away from open source and kind of the new licensing or wanting to develop to stop companies from making clones, which kind of goes against open source. Well, they moved all their PCB manufacturing in-house, which I think is a big sign that they're wanting to produce their own hardware and they're not wanting to give away the designs to these other companies because that's their bread and butter. Like, open source makes sense to an extent, but once you get to a point where you're spending hundreds of thousands, like when you're spending millions of dollars in engineering and then just opening that up to anyone to copy, you're not making the best business decision. Like at some point, you got to maintain your IP and make it harder for people to reverse engineer your stuff. At some point, no printer can exceed the quality of the model. I guess the speed being the difference, high reliability, and good quality can be had with almost any kind. Yep. Basically, all printers have virtually the same level of print quality. It's just a matter of, can you print a Benchy in 20 minutes or can you print it in an hour and 30 minutes? And often you end up with a really compromised Benchy when you print it in 20 minutes. So really, I view it as like a 2 times speed increase. The most expensive, highest end machines on the market can print about twice as fast. When you move faster than that, as Stefan pointed out in his latest video, CNC Kitchen, you start to sacrifice mechanical properties, which is not a good idea in my book. All right, so we've caught up on the comments. Thanks for all of your comments and the wild chat we've got going on right now. Really appreciate that. It's fun to read through. But now we're getting back to our EVA. So let's get all our parts ready. We got our belt. We've got this piece. Probably the most complex part on the whole printer. Pretty cool. Pretty neat little bit of engineering there. Let's see what else we got. I think I'll need this later, so I'm just going to prop that up right there. And we got this plate here. There's one tiny little part that I'm not sure where it is. I might have forgot to print it out. This one here. Oh, no, I know where that is. They're showing it at this weird angle, so it looks like a weird part, but really it looks like this. That's kind of hard to reconcile with that. So that's the part. We got it. Now we'll get our screws ready. So we need our blower fan. I'm just going to use a really cheap, crappy blower fan for now. Hopefully it's not too hard to change out later. I've definitely got some high-end blower fans that I want to install, but I do want to just slowly upgrade this thing over time and kind of do a part-by-part upgrade just to show you and demonstrate how getting more expensive components can benefit your printing experience. All right, now we need 13 M3 hex nuts. That's probably in here. I'll count out 13 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. 13, okay, now 2 M3 by 30 cap screws. That'll be in here. All right, so there's a bunch of different length screws in this bag. So this is another one where I'm going to have to actually measure things to make sure I'm getting the right one. So that's why having a pair of calipers is real handy. Oh shoot. We're dropping stuff a lot less today, but I finally dropped something. All right. There's our 2 here's our 2 M3 by 30s, and then 1 M3 by 25. Here's that. And then 1 M3 by 12. Where is our M3 by 12? Here's our M3 by 12 right there. And there's a timing belt, blower fan, two printed parts, and that's everything. So let's get on with the next phase of this build. We're preparing this EVA. So looks like we gotta pop a couple nuts in here. Fortunately, all the nuts for this step are the same size, so it should be easy to find where they go. Ta-da. All right. All right, 1, 2. Now I need to clean out these holes because some of them have this some stuff kind of laid into the holes just to make sure that they get printed correctly. But you got to clean them out. It's kind of like support material, but I've done this on my parts before. It makes sense to do. So we're just going to clean these out. So we've got 4, 5 to put in. We're going to use our Knipex pliers. I've heard people say it Knipex, like Knipex. Knipex? Are they Knipex or Knipex? Only the Germans are allowed to answer on this one. Ah, come on. Ah. All right, I think I got one up here. Ah, shoot. All right, those are more or less inserted now. All right. Now for the other piece, this one here, we got to put 3 screws in there. Let me just bore out these holes. I'll turn the exposure compensation down a little bit. When we're looking at the black parts on the printer, it tends to be a little bit too dark. And when we're looking at these white pieces on a white table, it's a little too bright. So here we go. All right, and here we go. And unfortunately, I've got to take a break for food in a little bit, but we're going to get as far as we can in the next 5 minutes. If anyone's got any final questions in the chat, let me know, and we'll have a chance to go over those at the very end. All right, and then I gotta drop this belt into this part. Unfortunately, it seems like this printed with a brim, so it kind of sealed up this little belt channel, which is a little bit annoying, but we'll do our best to clean this out. The Bamboo Lab printer automatically determines whether it needs to use a brim or not on various prints. And on this print, it decided it needed a brim. And even like on the same parts tray, if you print out 10 parts, it'll print brims on some of them and not on others. So it's a little bit of work to get this into usable shape. I think I'm gonna have to just like carve out each one of these individually to get that that belt in a condition where it can be installed. Thanks, Bamboo Lab. Ah, man, that's gonna be tough. Hooey. Maybe if I just shave off that whole kind of area. Yeah, this looks like it'll work. So I just basically shaved off this first couple layers, and we'll kind of dig out all of the plastic that has built up in there. And then, just for good measure, we'll hit it with the torch. Maybe that'll kind of help clear stuff up. Now we're looking pretty good. I need a skinnier tool to really get in there, almost like a razor blade. Take a look at that. It's getting cleaned up. So the smallest tool I have is this tiny little Allen wrench. We'll see. I don't think that's going to fit. We'll try it. Yeah. I really need like a pair of tweezers. Tweezers. I can't get in there to clean that out. How frustrating. Oh, I got something here. Oh, nice. So this is a kit. I forget what printer this came with, but we've got a really thin spatula. Looks like it can get in there. And it came with tweezers. So yeah, this part is requiring quite a bit of post-processing to get working. Alright, now let's see if that's cleared out enough that I can fit this belt in here. Oh, it's looking good. Awesome, alright. Blowtorch to the rescue. Blowtorch is always the answer. And if anything, I could have heated this up enough to soften the plastic and kind of squish it out of the way using the belt. So here we go. Nice secure fit there. And let's see what else we can do. I'm actually going to go through the chat and answer any lingering questions before we take off here. But so far, this was a pretty good stream. I think we got pretty far in terms of the build. All that we've got left to do is this tool head and then all of the wiring. So I'm thinking if we do one more stream, I'll be able to wrap everything up. I'll be able to at least get most of the wiring done and get this tool head installed. But yeah, I think the whole electrical part is going to take some time, and I always struggle with Clipper setting that up, so hopefully it won't be too difficult, but we'll see how it goes. So food is for the weak. That's true. I am weak. So second one is right. It's pronounced Nipex. Yeah, that's not helping me, King Sidorak. I can't tell which one is still the right answer. Second one is right. I don't remember what the second one was. I can't afford a Prusa, nor would I want one at this point, but I know there's a huge market for them. I own a Ender 3 V2, Ender 5 Pro, Aquila 400 XL. Wow, $50. That's a pretty good deal. As much as I don't want the closed system of the X1C and P1P, after I sell my house, I'm probably getting one or the other as a gift to myself for high-speed printing. Yeah, they're pretty cool. I mean, the market's changing extremely fast. Like the Bamboo Lab came out probably 6 months ago, 6 months to a year. I don't know the exact timeline. But as soon as that came out, every other 3D printer company was like, we're copying that. So Kitty Tech has already come out with their competitor in this in that segment, so there's going to be a lot to come. I'm going to review the K1 soon. So in terms of speed printing, the Bamboo Lab is no longer your only option. I mean, even the Prusa is fast enough to be able to do that at this point. I understand they're running a for-profit business and all. I'm not hating on them for that, but it might be seen as disingenuous to say open source if they move away from it. Bamboo is completely closed market system. It's done for a purpose and it's a targeted audience. Yeah, the Bamboo Lab, I mean, they just seem like they want to take everything over. Like, they're not sharing, they're copying everyone's innovations, they're making the best products that they can, which is, I don't know, it's good and bad. I love the channel. I found it by accident while looking for a BL Touch for a Volcano setup, and I've been in love since. The humor, presentation, and ingenuity is definitely worth subscribing. Thank you, Ken. Unfortunately, everyone here is probably already subscribed, but if you left that message to another audience, that would be extremely helpful. I understand why they want to do it, but it's kind of hard to say we are open source, but go against some of the tenets of the philosophy. Yeah, I think all of the connectors that they're using now are pretty specific. Instead of just generic JST connectors and screw terminals, they're moving towards like more higher performance, harder to source components. So it is open source in a sense, but it's kind of moving away from it at the same time. All right, recognition to people or companies that had an original idea. Yeah. It's pronounced like Niplex or Nozzlex from 3D. Right. It's pronounced Nipex. I may one day get something that I can plug and print if I start doing commission work, but if I get into 3D printing as a hobby, I love to tinker in a heavily modified Ender 3S1 Pro. Yep, and if you want to see pictures of Namion's setup, he posts them onto the Discord. So go ahead and join that. It's a link to it is posted on pretty much all of my videos. I haven't got around to adding it to my live streams yet, but they're pretty good. I love 3D printing. I used to work at a residential facility for kids. While we kept a printer on my desk for doing therapy with the kids, they loved it. It was therapeutic and engaging. I totally agree with that. Like, there's a very calming sensation that you get when you just watch layers of plastic being perfectly laid into place. That's awesome. And yeah, I'm familiar with those residential facilities for kids. I wasn't one of those kids, but I know some people that have worked at them, and that's really important work that you're doing. So keep it up. Um, for me, it's fun of what I can do with the printer, not so much of what I can print. Yep, I think that's definitely the crowd that I cater to the most. I think when you're modifying printers, that's like a different use case than what people are going to the Bamboo Lab printers for. But to Namion's point, if you're doing commission work and you're trying to scale up your production speed, there is a bit of a concern that I have for going over to the Bamboo Lab ecosystem. Because for me, I think the end game for them is going to be setting up a printing as a service kind of ecosystem where they're in control of who prints and who pays for things. Kind of like Uber. You know, Uber is just a platform for selling parts. But if Bamboo Lab can automatically commission and basically get people to be their little slaves to run their printers and send parts out, they could have a really competitive parts production infrastructure. If they control all the printers and they have all the cloud connectivity, they can send, issue, dispatch print jobs remotely and have you mail them out for them. Like, that could be hugely profitable. And the issue with using their printers at this point is you're basically handing over all of your IP and your copyright, your stuff that you designed and printed. Let's say you have a small business and you're printing little trinkets or 3D printed objects or some utilitarian object on your printers, and you're selling those. Well, you're probably selling them at a healthy profit margin, and by giving Bamboo Labs all of your information and all of the models that you're printing, they can easily look up your website and see, wow, these go for $60. Let's have someone reverse engineer it and print those out, and we can start selling them, or we can sell that information to someone else. I mean, just think about what Amazon does. When you sell something on Amazon, they know exactly how many you're selling, and they know, hey, if we come out with Amazon Basics versions of this, there's a market there, we can undercut these guys, we can take all that money and run with it. So that's kind of the issue with big data and centralizing all of this information in one place and trusting one company with it. So yeah, I mean, I'm really planning on doing a whole rant on this at some other point in time, but I like to talk about it. Food is for the week, definitely. When you print a brim, make sure that you set the brim on the outside only. It will keep stuff like this from happening. Well, that's true, but on this part, this is technically an outside surface. Like, this would be considered an inside surface right here, this hole. But this one's on the outside because it's, you know, it's like Pac-Man. It goes in and then it comes back out. So, yeah, that came up as an issue. Bamboo Lab detected part of another printer and decided to mess it up. Well, I mean, that's totally plausible. If you put a third-party device on Bamboo Lab, what's to keep them from sabotaging it? For example, I have a Sony camera, and they're coming out with features that they're only allowing Sony cameras to use, or Sony lenses to use. So they're like, oh yeah, you can buy whatever lens you want and put it on this camera and use it. But then they're limiting the frame rate that you can take pictures with, and they're limiting a lot of the autofocus features. So, I mean, they're kind of doing this thing where they're getting cred for being open source, but they're also like, hey, but you really should be buying our stuff at an inflated price. So, you know, we're gonna just have to wait and see how all those developments come out. I think Bamboo Lab's big thing is they have all these small disposable items on the printer that you need to repurchase from them, and that gives them an opportunity to sell you filament and stuff. So it's interesting. There's a whole world of making a business case and making a profitable company out of making 3D printers. I'm sorry, Dave. I can't let you print that. Yeah, that's what I'm worried about. So when you get all of these printers under remote cloud control, If you're printing something that Bamboo Lab doesn't want you to print, or if Bamboo Lab is approached by your government, let's say you live in Germany or you live in Russia or Ukraine, you know, stuff goes on there. If you live in the US, they might want to limit what you can print on your machines. And Bamboo Labs is building up an infrastructure to control what people are printing, which I don't know how I feel about that. Well, I mean, you can kind of read between the lines and understand that I don't really like it. You should get a set of microfiles. Yeah, probably. I think I've bought a set before, but I lost them. A lot of stuff goes missing in my lab. If you've seen a picture of my floor, you might understand why, but yeah. Thanks for leaving a link to the Discord, Namion. Yeah, just keep this conversation going. If you guys are having a good time, just hop over onto the Discord and keep the chat going. Don't forget about Perfect First Layer. Yep, Nathan, Guy, and JJ Schenkels will be filming another episode next week, and we'll have a lot to talk about. A lot has happened in the 3D printing market in the last couple of days, really. Yeah, Windows is basically operated waiting for people to make cool apps for it, and then they copy it and bake it into the OS to outcompete them. Yeah, it's true. Dave's Garbage channel has some interesting inside stories. Former employee at Microsoft during the heyday told a story how they were trying to hack a Messenger's user base. Yep, that makes sense. AOL had a backdoor in their chat software, and they knew it was Microsoft logging in and blocked them. In the end, MSN Messenger beat AOL Chat Messenger. Well, yeah, that's true, but nowadays, Microsoft has a way of taking things over and then running them into the ground. Like they bought Skype, and now nobody uses Skype. I think Discord is kind of the closest thing to the heyday of MSN and AOL Instant Messengers that were going on. You can probably find it next to the other stuff on the floor, like the Snapmaker. Yep. I actually threw the Snapmaker away. It's it's off to a recycling facility somewhere, most likely. So it will live another life as something hopefully more useful. All right, well, thanks for joining me for this live stream. We got pretty far with this printer today. It's pretty satisfying seeing this thing come together. Next steps will be to attach that tool head on here. I'll print out a couple of parts that I'm missing, and I'll get the electronics all ready to assemble. So it's either going to be 1 or 2 more streams to get this thing finished and printing, but it's been a pleasure, gentlemen, so I will see you in the next stream. Thank you, and make sure you subscribe and check out all my other videos. All right, and with that, I'm going to end it. See you guys later. Wait, we're almost at 4:20, but we're just going to have to end it 30 seconds early. We're 4:20 in spirit. Okay, see you guys.